I welcome Dr. Rekha Gupta, Dean, School of Commerce and Management, University, for the inaugural address. Dr. Rekha, now please take over the session.
Thank you very much. Am I audible to all of you?
Yes, ma'am.
Okay. Am I clear? Because your voice was not clear.
Yes, your voice is clear, ma'am.
All right. Thank you. So, on behalf of NIILM University Kaithal, I, Dr. Rekha Gupta, Dean School of Commerce and Management, extend a warm welcome to all of you in today's workshop on Statistics and Data Analysis with Excel, organized by Department of Mathematics and Center for Professional Development, NIILM University Kaithal. I extend my warm welcome to today's resource person, Dr. Vijay Kumar Gehlawat, Associate Professor and Associate Dean, Student Welfare, Department of Interdisciplinary Sciences, National Institute of Food Technology, Entrepreneurship and Management, Kundali. Welcome you, sir.
Thank you, ma'am. Thank you very much.
I welcome all the participants, all the research scholars in this workshop. The topic of workshop, that is statistics and data analysis, is of paramount importance, especially for the research scholar in today's era or this time, because no research can be performed without statistics and without data analysis. Statistics basically is what? It is data collection, data analysis, data interpretation, and data validation. And it itself includes all the tools of data analysis that we must know, and we must be aware of the changes that are coming and the new innovations coming in this field. And so we have the expert with us, Dr. Vijay Kumar Gehlawat. He will be enlightening us on the new aspects, or he will be, I hope, covering all the doubts all the research scholars have their mind. So I hope this session is going to be very fruitful, and the expertise, knowledge of sir and the deep understanding of the topic of him will make everybody understand the things very clearly. And so I hope we all will be listening him. And again, I extend a warm welcome and thank you so much, Dr. Vijay Kumar Gehlawat, for sparing your valuable time and joining us. Thank you.
Thank you, ma'am. Thank you very much. So, ma'am, can we start?
Yeah, of course you can start,
Okay,
please.
okay, ma'am. So, thank you, ma'am. Thank you, Rekha ji, Rajesh ji, Sunny.
Before you start, let me introduce yourself and welcome, sir.
Yes, ma'am.
Dr. Gehlawat,
Yes, ma'am.
an accomplished academician and researcher, serves as an associate professor and associate dean of student welfare in the Department of Interdisciplinary Sciences at NIILM Kaithal. He has 15 years of teaching and 20 years of research experience. He has contributed significantly with 46 research papers published in national and international journals and 35 conferences presentations. He has delivered many invited talks and chaired multiple sessions. Thank you, sir, for coming this session, and kindly please start the session.
Thank you, ma'am. So, good morning, everyone.
Good morning, sir.
I'm Vijay Kumar from the Department of Interdisciplinary Sciences, National Institute of Food Technology, Entrepreneurship and Management. And I'm very much thankful to the dean and the faculties and HODs and the honorable vice chancellor of the University of NIILM for giving me this opportunity to interact with the scholars and the faculty members on the topic this statistics and data analysis with help on this workshop with Excel. So as the ma'am has Rekha ma'am has fixed the tone for the workshop, that statistics and its what it is and how it is going to play. So I will start some discussion based on this statistics and data analysis. Then slowly we'll proceed towards that how that Excel can be utilized for some for the techniques, and whatever the time permits to us, what I had planned, I will try to cover up the basic concepts of the techniques and how those things can be utilized, can be used in Excel, so that we can save our time, as well as much more the things which are hidden inside the data, those can be those can be taken out, and we can make the wise decisions based on that. So, briefly, what I have planned for this session to be discussed with you all, that brief introduction about the statistics and data analysis. Almost both the things are same, plus minus certain variations are there with respect to time. Then everything need to be improved. Then brief introduction to Excel. I hope that everyone is having some basic understanding, maybe by training or by the use, they know something about this Excel. Then some specific applications, or you can say the applications in different dimensions of this academic and research environment. Then specifically to the techniques which I am targeting for this particular for today's discussions, this is descriptive statistics, then some inferential statistics. That these are the, you can say that if the statistics is being will try to divide into certain things, then two broad categorization will came into existence. One which can describe describe the statistics, describe the distributions of the data sets. Another one, when we do not have resources to deal with the entire population or the entire population, then we need to have rely on the samples. Then if samples are with us, how we can proceed to say that by studying the sample, how we can try to comment something about that population, whether the sample results which we have taken, the samples which we had selected, those are applicable to the entire population or not. That will be covered under this inferential statistics. And under this inferential statistics, certain things, some statistical tests which are most commonly used by everyone, and some we will move up to that analysis of variance in this one. So as the statistics, the four things came into mind, the three major things, and the fourth one is that based on our interpersonal skills, our understanding about the subjects, about the topics, or about the specialized field in which we are. Statistics is having, you can say, these four things in its definition. One is collection, means it belongs to the data collection, data presentation, data analysis, and later on the data interpretation part. So if you will see this data collection, there are different ways to collect the data. Maybe the data may be qualitative, may be quantitative. If it is quantitative, then there are different ways to collect the data. Maybe we have to get the fresh data that is named as the primary data. Maybe we have to go for rely on the literature, maybe on the books, maybe on the research journals. Research papers need to be extracted for finding the gaps. So that you can say the broadly the primary data and the secondary data. Under them, different ways are there to collect that data. Then data presentation, you can present the data with the help of tables, with the help of graphs, so that the main purpose of the presentation is there. Whenever the raw data is with us, how that raw data can be interpreted, what kind of things can be extracted from that data. For that purpose, we need to present the data in a useful form, maybe in tabular form. And based on, yes, initially it will be in tabular form, and later on it will be proceeded to some techniques, analysis techniques that can be graphical technique, or that may be descriptive or inferential statistics can be utilized for that purpose. So when we are coming to this third thing, that is data analysis. Data analysis means, well, data is ready with us, and we hope that the data which we are having, that is very good data, means very good means it is going to represent the objective. It is going to represent the population from where it is being drawn. So it is free from all kind of biases. It should not be like that ki if I'm, let's say I'm a teacher and I'm going to ask certain questions in my class. So it doesn't mean ki that I'm going to target only the students who are very much sitting in the first row, or maybe sitting on the last row. That selection should be done randomly so that I can get the idea about the class, that how class is performing, how class is attentive to the things which I am trying to convey to them. If my sample is very much, you can say, the biased, where I feel that the students who are sitting in front of me, they might be or they may be very much sincere and they are listening, then I may be wrong. Then in the end of the semester, in the end of the year, the result may not be as per the expectations based on which we are trying to discuss among the students. So data analysis will cover that thing. The technique need to be identified. The important thing in this data analysis, being a researcher, we must be capable to understand what type of data I'm having and what kind of analysis need to be performed on that. Means right data, right technique to be identified, and in the right way we can perform it. With all of these things should be in an optimized way. For example, the broad categorization of data, if we are talking about, there are two, the qualitative data and quantitative data. So before proceeding, let me discuss that thing, which are the four, there are four basic scales. Just hold 1 second. I hope this that the slide titled measurement and scaling is visible to all.
Yes, it
Yes, sir,
is.
it's visible.
Okay, thank you. So the measurement and scaling means we need to measure something. Then we need to develop our scale. Scale can be like, you can say, this is a scale. We have decided, we have finalized this is 1 centimeter, 1 inch, 2 inch, etc. In the same manner, we need to develop our scale. So scale or measurement means how we can measure. For example, I need to measure my height or the height of the students, weight of the students, BMI of the students, or you can say the in the present time, the different kind of ranking of the institutions are going on. So all of those things need to be measured. So the experts, subject experts and the field experts, maybe you need to develop your measurement. See how I need to measure that, maybe in centimeters, maybe in inches, maybe in qualitative terms, maybe in quantitative terms. Then for that purpose, we need to develop some scale. See how these things can be measured and what are their meaning for that purpose. For example, these are roll numbers. For example, to identify the students, we fix some certain roll numbers, enrollment IDs, Aadhaar numbers, PAN card numbers, hostel room numbers. University, for example, if you are talking about the higher education department, then higher education department is going to allot certain kind of codes to the universities or the institutes. All those things are under this purview of this measurement and scaling. And these are nothing but these are mathematical properties of the numbers which we are going to use for the purpose of our making our life easy. So these four major primary scales of measurements are there: the nominal, ordinal, interval, and ratio. The nominal scale, it is, you can say, the very first one scale. Actually, when we are talking about the mathematical numbers are having certain characteristics. Characteristics means the mathematical numbers are used for certain purposes. Whether that purpose is to reflect the qualitative things or the quantitative things, these two broad categorizations. So respectively, these four things came into existence. The nominal and ordinal, these are usually for the qualitative data. Usually, we prefer to use this nominal scale and ordinal scale. And the remaining two, that is interval scale and ratio scale, these are used usually for quantitative data. So the measurement means we are going to assign certain numbers or certain symbols or characteristics to certain objects according to some pre-specified rules. For example, in my organization, we had developed a strategy to assign the room numbers, classroom numbers, based on, you can say, ground floor, it is 001, first floor 101, second floor 202. In the same manner, we decided to, the administration planned to allot the roll numbers to the students based on year. For example, one batch, for example, B.Tech, if some student is there, so in the beginning, in B.Tech, the roll numbers will start with 125. Means 25, for example, the new batch which is going to come out, there it will be 125 is indicating about that year. One means the B.Tech, the first course of the organization. 25 is the year when the student has enrolled, then 001, 002, 003, like that. In the same manner, if different codes are there, I think the same thing is happening in NIILM as well. They had made certain kind of rules to measure so that the things can be identified. And these rules are non-overlapping, and it's not like that ki 1 year we have this rule and our next year we will change the rule. We will try to keep them throughout, maybe for next 10, 20, 30, 40, 50, 100 years. The same pattern can be utilized. So scaling is creating a continuum 10, 20, 30, 40, 1, 2, 3, 4. Whether in terms of qualitative things, if you can see that extremely favorable, extremely unfavorable in this way, then these four things are there. For what purpose? The properties of the mathematical numbers which are being used in the mathematical system. Mathematical numbers are used for the identification purpose, for the magnitude purpose. Magnitude means magnitude or size, equal intervals, absolute and true zero. So I will try to spend 5 minutes on these things, because it is very much essential. Whenever we are going to get our data, we should know it is under which category, so that respectively we can fix that this is the scale for this my variable. For example, we are running a question here. It starts with the name of the participant, Aadhaar number of the participants, roll number of the participants. The purpose of this, all these three, the name, Aadhaar number, roll number, etc., their purpose is just to identify the participant of that interview, participant of that particular survey, or who is participating by filling that questionnaire. He is trying to give that. So we want to identify. So identification can be done. Maybe it's a number, like roll number. Maybe it's a name. Maybe it's a mixture of name and name and number. Means the A, B, C, D and the numbers are in all are together in that one. Those are used for that identification purpose. So with respect to this identity, only one scale is there. That scale is named as nominal. The purpose of the nominal scale is to just to identify. Here, what kind of statistical operations we can perform? Those operations can be, you can say, maximum we can count. For example, in this particular workshop, maybe there are 100 of the participants are there. So we can assign them serial number, maybe the registration number 001, 002, and maximum thing what we can do, the purpose of those 001, 101, 002, 003, etc. is just to count. We can count them by utilizing them, that thing, and we can also try to identify them, or only this purpose. Then the second property of this mathematical number system is magnitude. Magnitude, or you can say the size. Here, it is better than that nominal, because it is having some other additional thing is there. The identity is by default in this one, the magnitude. Magnitude or size means, let's say there are these two objects are there with me. One is this. Then I think we can easily identify which one is fat, which one is having more size, which one is having less size, or maybe these two pen drives which I'm having. Based on the size, we can say this pen drive is small, this pen drive is large. Just by the physical appearance, we are trying to identify. If you do remember, when we were in the school and in the morning assembly, when we go there, usually the physical teacher is there. He usually maintain the queue, that the students who are having height comparatively less, they can come in front, and the students with more height, they can go in the back. So their purpose is just to arrange the things with respect to size or with respect to magnitude. So this is the second property of the mathematical number, that is magnitude. So in this magnitude, we cannot say that 2, 4, 6, 8 all are at the equidistant. They may be, mathematically we are trying to say that 2, 4, but it doesn't mean when we are saying 2 and 4. 4 doesn't mean it may be as much just double to that 4, because this is related to the quality aspects. Then the third scale, that is based on these equal intervals, means when we are specifying some continuum 2, 4, 6, 8, the exact meaning, exact sense will come out of this. That one guy is 2 centimeter taller than the another one, another guy is 4 centimeter taller than the another guy. So that is the exact interval. Means with respect to this equal interval and the absolute or true equal interval, we starts with the quantitative data. We need to quantify the things. That's why this equal interval exists. And the last one, you can say that absolute or true zero. Equal interval, identity, magnitude, equal interval. Absolute or true zero is the topmost. You can say it is having all these properties of equal interval, magnitude, as well as identity. So true zero means, for example, we are saying that that we are going to market, and we need to purchase something. The basic characteristics to purchase, it's money. If money is available with us, then we can purchase the things. If we have 100 rupees, then we can purchase for 100 rupees. If we have 200 rupees, we can purchase for 200 rupees. But if we do not have money, then what we can do? We can go to the market, we can do window shopping, and we can come back. So true zero means when certain characteristics is absent, then that can be represented as zero. Means this thing is, for example, money is not available, so I cannot make the purchase. So that is, and respectively, let me show you one slide where, look at this. Here, you can say these scales of measurements, nominal scales. This is an example where you can see that some athletes are there. They are standing for their number. Some numbers are assigned to them: 1, 2, 3, 4, 6, 7, 8. The number which are on their chest or on their back, they are just to identify. Number 1 belongs to Rahul. Number 2 belongs to Rakesh. Number 3 belongs to Vijay, etc. Then the nominal scale, it is indicating about that number so that we can identify them. Then the ordinal means the rank order of winners, means the result is being declared, and who is the topmost, the first, second, and third. Those things are being identified. Based on that, this is the ordinal. But here we are not specifying how much better performance of one to second position holder to third position holder. Then the third one is equal interval. Here the performance rating on the, usually this equal interval or the performance rating, when we are talking about here, some experts will be involved in this one. The experts will specify the maybe the way of the stance, how the athletes had started their race, and how they ended their race. And in between, there are some technicalities where some technical experts can give the ratings out of that based on their performance. It may be possible that maybe winner is someone else, and the better technical evaluation is going to maybe the performer number 2 or the performer number 3. It's based on that specific quantification, the performance given by the experts. Then the fourth one, the ratio. In this ratio scale, it is being mentioned that the exact time to finish the race: 13.4 seconds, 14.1 seconds, 15.2 seconds. So these four scales are the basis for any kind of data. We need to specify, we need to understand, if we have 10 variables in our study, then which variable belong to which scale. Because these scales, for qualitative, the first two are majorly for the qualitative, the next two are majorly for the quantitative variables. I hope I am able to clear these aspects of the basics for this number system and how this can be. If anyone have any questions, any doubt on this nominal, ordinal, interval, and ratio scale.
Going good, sir. Please continue.
Thank you, ma'am.
Actually, sir, the slide is not visible. The updated slide that you are just discussing, it's not visible.
Okay.
We are just stuck on the first slide only.
So let me reshare it again. So in between, you
Yes,
can
sir.
please,
Yes, sir. Please.
please let me know whenever something is happening. You can interpret. You can stop me in between, and you can try to ask. I hope now it is visible to you.
Yes.
Yes, sir. Now it's okay, sir. Yes.
Okay. So this was the slide which we were discussing, based on which is specifying about these different scales of the measurements: nominal, ordinal, interval, and ratio. The first two, nominal and ordinal, are for the qualitative data, and the next two are for the quantitative data. With this example, we tried to explain explained all these four for what purpose, what is their purpose, and so that you can try to align the things with respect to your own requirements. Under which category this variable can be, this variable is. So let me come back. I hope this one is visible, where the statistics is being written: collection, presentation, analysis, and interpretation.
Yes, sir.
Okay, thank you. So the main purpose of this statistics is to understand the complex information of different situations. Different situations means maybe the certain situation you are working in the engineering aspects. So you have some data related to the engineering, some equipment design, some equipment machine, and you are trying to understand what that data trying to tell you. Maybe if you are a social scientist, then you must have some data about the behavior, about the behavior of the people, related to one kind of advertisement, related to one kind of new product which is there in the market. Then you are trying to understand whether the customers are feeling, consumers are feeling satisfied with that or not feeling satisfied. If you are a political scientist, you are working in that direction, then you may be interested, that whatever the policies are government is going to, government has announced, how much it is penetrating to the people, how much it is beneficial for the society, beneficial for the people of our state, of our country. So when we get the data, the different respondent may give different responses. So this statistics can try to assist us to get to get some information out of that complex information structure which we collected, and make some decisions. Yes, this policy is okay, or this policy needs certain modifications, so that the same thing can be submitted to the concerned authorities, so that they can take initiative, so that it can serve the purpose. Then specifically in data analysis, you can say as the title of this workshop is statistics and data analysis. So it is almost you can say the same with respect to this, our statistics, the data analysis. It starts with this data cleaning, means data is being collected and we need to refine it, because when we collect the data, there are certain, we may observe certain disturbances in the data. So we need to remove those disturbances. For example, if we are talking about in some industries, example, if industry usually when the specifically in the food industry, if you are talking about, if let's say one biscuit manufacturing company is there, and they have started their production in the first shift at 8 a.m. So when they are going to initiate some equipments, there are certain vibrations in the machine. And when whatever the products are there inside that, at that stage, maybe the first two loads, first one load, they may have to reprocess it, because due to those vibrations, due to those settings, the quality of the biscuits may not be appropriate for the consumers. The quality may be the protein content inside that, maybe the sugar inside that, maybe the structure of the biscuit which is being advertised, it is not like that. So they need to do cleaning for that. They may start that it is going to, we are going to assume the production, if this plant starts at 8, then maybe 8:30 the first batch can be sent for the packaging purposes. Then after data cleaning, we need to explore the data. So data is there after cleaning. So we can say the data is much more refined. Then we need to explore that data, how that can be done by making those tables, charts, etc. Then statistical analysis means the different statistical techniques which are very much relevant to those data. Only those can be performed on that. And then we can get the results. And based on those results, we can try to interpret those results. What these results are trying to comment based on the objectives, for what purpose, for the purpose for which we collected that data. And in the end, we are trying to represent those findings, or you can say in a form of report we are going to initiate. So almost statistics and data analysis, you can say the statistics is the superset, data analysis is part of that thing. It is more specified with respect to the analysis aspect of that data. So certain functions of the statistics: numerical and definite expressions of the facts. Facts means the data which we are going to collect numerically, we are trying to fix them by defining some certain things. And simple and condensed presentation of the data. Maybe, for example, we are conducting the examinations, and there are 10 questions in the examinations. So when evaluator is evaluating, all the 10 questions are being evaluated, and in the end, he is going to give the marks to student 1, 2, 3. It may be possible that the controller of examination is going to ask, give the input of how total marks, how many in each question, how many marks student has received. At that time, the situation, the structure of that data set will be a little bit complex, but later on it can be further scrutinized, and we can try to make it more simple and condensed. In the end, we are going to tell subject 1, student 1 has received 80 marks. Subject 2, he has received 10 marks. So in that way, to provide techniques for making comparisons, if you want to compare 2 or more than 2 data sets, then statistics is there. To establish the relationship between facts, we will try to see whether the two variables are related with each other or not. Then relationship studies can be done. Then enlargement of the individual knowledge and experience helpful in formulation of the policies for all, not only the government, for the institute, for the individual, everyone. With the help of that data which is available to them, they can try to formulate those policies. Formulate and test of hypothesis. We can if specifically we are going for the research, then we need to define our problems. After identification, we need to define our problems. Then problems, when we are formulating those problems, different variables need to be identified. Those variables may be of qualitative type and quantitative type. And then certain assumptions need to be made based on researcher intuition, based on the literature gap which we identified, and we develop those hypotheses, and then we try to test those hypotheses by applying these statistical techniques. And definitely helpful in the forecasting. Basic techniques is regression analysis, which can be used for the forecasting, time series analysis, and further there are more enhancements in that. Those things can be utilized. So as we see that this data analysis and statistics, data collection, presentation, analysis, and interpretation. So collection means the primary data, secondary data. We want to collect that. Presentation means we can present in the tabulation form, frequency distribution, graphical presentation, etc. Analysis means when data is there in the table in a very much representable condensed form, then what kind of interpretation we can make out by identifying the appropriate statistical technique, whether it is central tendencies, dispersions, skewness, kurtosis, correlation regression, whether it is inferential statistics, t-test, z-test, ANOVA, rank test, etc. Whether it is design of analysis of experiment, time series analysis, there are more things are there under this analysis. Then interpretation based on the objectives, based on the output which is coming out, what an individual who is having that expertise, he or she feels that this output is giving this kind of indication. So that can be write down in that final interpretation of that, in light with the basic concepts and understanding of those, in light of the basic concepts of the statistical technique. Then before going to these applications, there is one very common term. You can say statistics. There are three types of lies. One is lie, one is white lie, जिसको हम बोलते हैं सफेद झूठ, and third one is statistics. So when we are using these statistics, we must be very much careful about it. We must be very much careful about it, because statistics can prove and disprove anything. It depends on the guy or the person who is going to utilize it. You might have heard about different kinds of ethical issues, ethical concerns come out after 2 years of the publication of some research work, after 5 years, after 10 years. Those are because they play with the data. The researchers whose names are there coming out after 2 years, 3 years, 5 years, they applied some lazy approach when they are collecting the data, when they are representing those facts. Sometimes what happened, without conducting experiment, they generate the data and they try to prove with respect to their objective. So those things, you can say, the biggest lie is statistics. It depends on the individual who is going to utilize it. We must be very much careful. We should be honest in our procedures. We must be honest in our representation. If we do not have data of the 100 participants and we have only 50 participants, then we should represent only for those 50 participant information. Otherwise, the entire scenario will be changed and reflected totally differently. Then applications, research and development, very huge. There is not a single line, single discipline where statistics is not being utilized. Whether it is research and development in different disciplines, healthcare systems, social sciences, business, industries, quality control, agriculture and food sciences, and list is so long. These are some of the, you can say, the experimental designs can be utilized: quality control, sensory analysis, self-life estimation, risk assessment, consumer research, process optimization, product development, food safety, microbiology, data analysis and modeling. In all these things, statistics can be utilized. Anyone have any questions? Question on this? Anyone have any doubt, any question till now, whatever we discussed? Then we proceed with some exercise
No,
in.
sir.
Okay, thank you. We proceed with some, let's say that tabular presentation of the data. I hope this slide is visible to you. The Excel sheet is
Yes,
visible to you.
sir.
Okay, good.
Yes, sir.
I understand that everyone is having some basic idea about this Excel. So Excel is nothing. It's just like we are going to represent the data into rows and columns. So Excel is a digital form through in which we can represent the data, whether it is qualitative or quantitative, in the rows and different columns. So we had one question here. We have some data. Let's say we have a company and we are owner of that multinational home appliance. We are heading this particular organization. Uh, so owner of a multinational home appliance retailer. We are doing, and we have huge data with us, and the data which is available with us, it is related to this. This data is dummy data. I have taken it from internet. So there are these 5-7 variables are there in this data. The first one is the store information, means where the retailer that home appliance companies stores are available. These are the different locations of those stores, different cities. Then these are second column is about the countries who are looking after those things. Then third one is the region, whether north, south, east, or maybe something which is being specified like Haryana, Punjab, Jammu Kashmir, etc. Then some date information, on which date that this store was there, it was installed or make functional at that part. These are the items: microwave, air conditioner, ceiling fan, etc. All the home appliances are there. And then under this heading F, the salesperson, who are the sales representative of those companies of our company in those different regions who are being deployed. And this is the list price, actual price, and discounts offered. So with respect to the first thing which we discussed in the beginning, that the measurement and scaling. So this store, this is variable one. You can say, let's name it variable as, this is variable x1, x2, x3, x4, x5, x6, x7, x8, x9. So total 9 variables are there in our study. So let's see these variables are of what type. This, for example, if you will see that the store names are there, the locations are there. Its purpose, this is a nominal variable. It's at nominal level. Only we want to locate where that store is. Maybe we can give the numbers to this. For example, Moscow given number 1, Toronto can be given number 2, Sao Paulo, Istanbul can be given number 4, 5, etc. Then country, name of the country, this is also nominal scale data. Then the region also we specified, this is also nominal scale data. Date is also nominal. We are trying to specify the date with specific date. Then the item, name of the item is also nominal scale, and the salesperson is also nominal scale. Maybe instead of their names, we can give some identity number, their employee ID numbers. Then the last 3 variables, the list price, actual price, and discount. All these are quantitative data. Maybe these are the true zero, or you can say the ratio scale data, or interval plus ratio scale, both can be merged together. They can say this is the quantitative data. So in this study, in this data, these 3 variables are totally quantitative, and these first 5, 6, 7, 4, 5 variables are qualitative variables. So now what we can do, Excel is having this different pivot tables. We can do some kind of understanding, develop from this data. And this data belongs to, you can say there are 500, 700 entries are there in this data set. So let's see, we are trying to answer 3-4 questions. The first question, which is here, if you are able to see it, how much in dollar did you sell in each city? From that data, we need to extract this information. How much sale happened in each city for these different products. So for that purpose, we need to develop our, we need to go to that pivot table, and sales, actual price, store, and region need to be identified. So I'm coming back to this data, and here, if you will click on this insert, so first we'll need to click on this insert, then here we need to click on the pivot table. If we'll click on this pivot table, it will ask us the input range, the data range, on which data you want to create table. So we need to select the data. So let's select this data. So data is being selected. Then it is going to ask you choose where you want to want the pivot table report to be placed, means where you want the output. By default, it will give you the, maybe it's our choice whether we want to give the existing sheet or maybe the new worksheet. So let's select the new worksheet and then click OK. So when we clicked OK, on the right hand side, you can see here the pivot table fields are being mentioned. I hope it is visible to you, the pivot table fields. So here different variables which are there are being listed: the store, country, region, date, item, salesperson, list, actual, discount, etc. And here these are the four boxes are being mentioned here: the filters, column, rows, values. So the first we will target these first two, the columns and rows. Columns and rows means which variable we want to put in columns, some variable we need to be selected into rows, placed into rows. So I'm again going back to the question. What question need to be done? The question is how much sale, how much we are able to sell in each city. So this is our question, and for this one we need to select two potential variable. One variable that is store and actual price. Store and actual price. So data pivot sheet 1. The sheet 1 is being created automatically for this pivot table. So we had selected the store. When we are selecting the store, the row by default automatically in this Excel sheet, the row tables are being represented with respect to the store locations. And then the actual price, when we are selecting, the actual price came into this particular second column. The sum of actual prices is being there. I hope this one is okay with you. Then we can copy this data, or maybe we can make highlight this data and we can try to understand. The first question was there. This was the initial, the huge data is there available with us based on these 7-8 variables. Now out of this entire data, we need to extract the information that how much city-wise we are able to make the sale, actual sale, in terms of money, in terms of dollars or in rupees. So by utilizing this pivot table, we inserted and we obtained this particular answer of that from that clumsy data, complex data. We extracted the specific information by simply utilizing Excel's pivot table. This is one. Then the second question of this one, another exercise which I tried to show you, that it is about each home per each home appliance item, how many items were sold by your company? कि आपकी कंपनी ने कितने आइटम्स एयर कंडीशंस, होम अप्लायंसेस मींस एयर कंडीशंस, सीलिंग फैन, डिशवॉशर, आयरन, माइक्रोवेव एटसेट्रा, we want this kind of output. So for that purpose, what we need to do, we need to again go to the data, the main data, and we need to again click on that insert, then again need to click on that pivot table, and again need to select this data. So let's select this data. The data is being selected. And then again, let's put the output in the new worksheet. Then click OK. The pivot field maybe is not okay. Let me reselect the data. So data is being selected. Earlier, what happened? The entire sheet was selected. That's why it didn't consider it. So again, I clicked on that. You can say that pivot table is being inserted. Now the question is, again, let me go back to the question. We need to how many items were sold by your company. So sheet number 2, the pivot table, how number item. There is one variable named as item. So select this item 1. So when we are selecting here by default, first it will go to the rows. So this row data, these are the different items which our company sold, are manufacturing, and we are doing business in these different items. Now then we need to select this and put this into this in this fourth quadrant, or you can say the values. आइटम वाले वेरिएबल को उठा के हमें इसके अंदर डालना है. When we put it here, automatically the pivot table created for these different items, and there the count ki how many items, washing machines we are able to sell, microwave we are able to sell, dishwasher we are able to sell. So there are also different options are available. For example, view this field setting. We can find the average, we can find the sum, we can find the max, minimum, we can find standard deviation, etc. All these things can be obtained from this particular, you can say, where these summation values are being mentioned. We can perform that thing. This is the second question. What we did from this used data, we extracted the information only specific to these items. Items means these items, and how many products are we are able to sold out. I hope it is clear to you about this particular second application of this pivot table with respect to this data. Means the entire clumsy data is there. There is some specific information we are trying to extract. So Excel is providing this facility to us that with the help of pivot tables, we can extract the desired information very quickly and very accurately. And later on, we can make that further decisions on that, because data is available, data is facts are with us, and we can make the decisions on that. Then let's do another question. Then we'll proceed for the next one. Here, this question is about create a table which shows a breakdown of total revenue from each of the items sold and regions each item was sold. Means region wise, the total revenue generated with respect to these different items. So two variables, the items and regions need to be identified. So what we do in this one, in rows we will represent the items, in column we will represent the regions. So let's see how we can perform. Again, we need to go to that entire main data sheet. So main data sheet is opened, and again insert and go to this pivot table and then select the data. Now there are some Excel shortcut commands are also there, where through this time which I'm doing, like dragging this can that time can also be saved. So data is being selected. Then again, it is going to ask you where you want to see the pivot table as output. So let's select the new worksheet, then click OK. So another sheet 3 is being created for the question number 3. And here we need to put this item into rows. And the second was the sales region into columns. So when we are doing it, this table is being created. The first row is about this particular, you can say, this sales, and the second row, these are the different, you can say, these are the different regions. Here the regions names are mentioned as APAC, EMEA, LATAM, NA, and grand total of these. So now we want that in these regions, how many refrigerators are being sold, how many ceiling fans are being sold, etc. So for that, what we need to do here in the fourth column on the right hand side bottom, you will find that values. So here we want that the information of these items, these different home appliances, how many number are being sold in different regions, so that further some decisions can be made out of that thing. Maybe salesperson is responsible for that. Maybe some marketing strategy need to be updated for that particular region if the sales are more and less. Comparatively, we can, so that we can strategically plan and we can penetrate in the market. So this item is being selected and again dragged into these values. So when we are dragging it into values, automatically by default, the count of item is being mentioned. So now you can see here. This indicates that with respect to these products, so this pivot table assists us to provide this specific information, that air conditions in region 1, 2, 3, 4. Total air conditions we are able to solve 195, 54 in this region, 82 in this region, 26 into this region, and NA means this is some another location or not specified, something like that. This is 33 are we are able to sell out in this particular region. And here in the bottom, you can say the overall region wise grand total of these different items is also being there. If you can see here, maybe the company is having the same strategy. Our company is having the same marketing strategy to penetrate for all these items. So, but the differences can be identified. Maybe for this specifically, maybe any one of these, let's say select this coffee grinder. You can see in this region 1, 53 items are being sold for this specific machine, coffee grinding machine. Then in the second region, 77, third region, 27, fourth region, 32. Then we may try to find out the reason for that. We may try to discuss. And if we find that maybe all the things are being okay with respect to the financial status or the living status of the people of that particular areas, that region 1, 2, 3, 4. If then the same strategy we have applied, then why we are not able to solve the almost very near to each other these number of items. Otherwise, maybe some other things can be come out. The financial status of the requirement of the people are different. That's why it is happening. The same manner for these different, let's say this iron. Again, if we can try to see that 60, 100, 35, 44, then O1, we can try to see the difference. And also we can try to see from here that this area, this particular region is more specific to this EMEA, the region is having more demand as compared to other regions. So maybe some more premium products are required for this particular region, and so that some for that purpose, some specific data, specific research team need to focus on that particular area, so that the information can be extracted from the respondents with the help of some interviews, with the help of some questionnaires, so that their requirements can be asked, because they may have a very good paying capacity and they can go for those new product which we want to which we want to develop in our research and development center for the betterment of those particular society. In the same manner, here you can say here in this region, here the sales are comparatively less from all of them. Then maybe we want to identify the reason why it is happening. We need to go to the population, we need to get some sample, and we need to extract certain information why it is happening. Maybe the products are not as per their requirements. So we need to prepare for some specific product as per their requirement, as per their budget levels, and we can target them in a much better way for the further improvements in our organizations, our company's profitability, etc. I hope it is clear to you. This is you can say uh, some idea about this, how we can utilize these pivot tables in Excel to briefly summarize our very complex data with respect to we'll try to extract the specific information out of that. Anyone have any question in this specifically, you can say for this pivot table of this Excel? Okay, then we are proceeding further. Another very important thing you can say, that normal curve. I hope, let me share it first, the normal curve. I hope everyone must have heard about this particular this kind of shape of the curve. This is called normal curve or bell-shaped curve. This is called normal curve or bell-shaped curve. Then for the data, we can create this bell-shaped curve. This bell-shaped curve, let's just try to link with our day-to-day life. Then we will come to this particular example. It is about, you can say, when we are going to some of our relatives, or maybe when daily we are reaching to our university for our work, for our job, or maybe in some society we are going, everyone we are trying to ask, हाथ वाथ मिला के हाँ भाई कैसे हो, how are you, क्या कर रहे हो, सब ठीक ठाक चल रहा है. तो every time we are getting the answer, and maybe we are even we are the respondent, we are saying okay, all okay, सब ठीक चल रहा है. But it doesn't mean कि सब कुछ ठीक चल रहा है. When we are saying that सब ठीक चल रहा है means we are talking about this particular top of this curve, normal curve. सब ठीक चलना means this particular region. Plus minus certain variation कि यहाँ तक okay. Majority of the times when we are saying ठंड कैसा है, अच्छा है, सब ठीक है. But every time it doesn't mean कि everything is good. All are सब ठीक. No. Every time in every situation some extremes are also always there. Some may be very much extremely overwhelmed. बहुत ज्यादा खुश होते हैं जब हम किसी के से मिलते हैं. कुछ ऐसे होंगे एलिमेंट्स जो बहुत ज्यादा परेशान हो जाएंगे हमें मिलके. हाँ, रिफ्लेक्शन में कहेंगे सब ठीक है. In our day-to-day life when we are saying, so this is about that normality. If 100 people we are targeting, we are meeting, then maybe 80 are okay, 10 are very okay, 10 are 5 to 10 maybe not so much okay. So that is about this normality. Now again, let's discuss one example, as we majority of us are teachers and maybe the researchers and the future teachers. So when we are analyzing the performance of the students, in examinations, so we out of 100 we are evaluating them, and the controller of examination is asking to submit us the result, and we are submitting the result of 100 students or 50 students or to how many number of students are there. So the first thing the controller of examination should do, or I hope everyone is doing that, they try to get the data of subject 1, subject A, B, C, its marks, and he or she will try to draw this normal curve of that thing. If the curve is coming something like that, normal curve, it indicates that result is okay. Okay means this central part is indicating about the average marks of that entire class. This right hand side near to this X, this indicates about that some students are performing extremely very well, and this lower part is that some students are very poor in that particular subject. If it is something like that, then it will be very good. If it is not like that, then there may be problems. Problems may be in the level of the understanding of the students. Maybe all students during what happened during this COVID-19, what I observed when I tried to prepare this normal curve of the students, the results, because the exams were online. So the curve shape was something like this. It was towards the higher side. That was skewed curve. Skewed curve, it indicates that the majority of the students have skewed marks more than average, means more than expected. It indicates something. Then two things may come out of this, that either the question paper was so simple that everyone is able to do it very well. Second thing, the students were so intelligent that they are able, all of them are able to perform so well that they are nearing to that all the 100 marks. Third thing, the what kind of after making this normal curve which came out, the third thing that there was mass cheating was done by the students, because they are at their home and online they are trying to do, they did the cheating, and that's why the majority of the students are on the near to 100 marks. So that indicates. In another side, you can say if the physical examination system is happening and the students, the curve is more peaked on this left hand side, it indicates that students performance is very poor. Student performance is very poor. Very poor means maybe the students were not prepared for the examinations. Maybe second thing, maybe the students were not discussed about that particular course and directly the examination is being taken. The third thing which we can make the interpretation as that the question paper was so hard that was beyond the level of those students. So these 3-4 interpretations can be made out of that thing. So how we can make a normal curve whenever we have a data with the help of Excel, how this normal curve can be made. So for that purpose, first we need to enter the data into Excel. Then we need to get the mean and standard deviation of that data, because normal curve is a normal probability distribution. Based on that distribution, this curve will be developed, that there is a density function of the distribution. Then we will find the normal probabilities using the inbuilt function of Excel, this norm.dist. I will try to perform and try to show you. Then this command for this norm.dist, this is the specific command. It will ask that one number, one variable based on which we are trying to initiate the mean, standard deviation, and true and false. This is for the cumulative things. We'll let you know. Then for that, we need to click on the insert line chart, select data. So let's say, let me open that Excel sheet where this normal curve we can draw once. Draw normal curve. Here it is. I hope this data is visible to you. This Excel sheet is visible to you.
Yes, sir.
Okay, thank you. So let's say this is the data which I have randomly selected. That these are the marks of the students obtained in one subject, and the total, you can say, the total students are 36. This data belongs to 36 students. The marks are up to 50 to 120. We are assuming that the question paper was of 150 marks, and these are the marks which we received, which students have received. Then let's say if initially we can find the mean and standard deviation. This data is having mean for this data is 85. How we can see that we can also calculate with the help of some inbuilt functions, and also we can use we can call those functions and we can develop that. Another thing, by default, automatically we can we can know about the average and the total count of these. Select this data, and on the right hand side on the bottom of this Excel sheet, here we can see that the average is 85, count is 36, and sum of all these marks is 3060. Then also we can calculate the mean. How we can calculate? Whenever in Excel, we need to call some inbuilt function. We need to start with this symbol equal to, and then one function name is average, EAV, average. When we type this AV, automatically it will show all the commands, all the inbuilt functions of this Excel. It will be reflected, the average. Click on this average, and then it will ask you the data. Then average, start bracket, then select this data. So data is being selected, then close the bracket and press enter. So mean is being calculated, that is 85. In the same manner, standard deviation can also be calculated. The standard deviation which 11 is here is being taken. This is not the right for this data. This is for the population, entire populations. Based on the past experience, this data came out. So how we can get the standard deviation of this one? Again, the equal to symbol, then standard deviation STD. Here in the second last, STD, standard deviation. Now select this data in the same manner and close the bracket and press enter. The standard deviation for this data came out 21.07. Now we need to, first thing, whenever the data is there, we need to arrange the data in ascending order. So data is being arranged in this column here. And then we need to get the probability density. Probability density, if you do remember in our childhood when we were in class 3, 4, that raw data was given to us in mathematics books, and data need to be converted into two forms by using tally. Maybe If data is smaller, we can develop it as a continuous, is a discrete frequency distribution. Discrete frequency distribution means, for example, here in this data, 50 marks. How many students obtained 50 marks? 50, number of students 1. 20, 80, number of students 5. 79, number of students 88, maybe 10. So like that, that is called discrete frequency distribution. So when two broad categorization of frequency distributions, one is discrete, one is continuous. Continuous frequency distribution means the range is being created 50 to 55, how many students obtain marks? 55 to 60, how many students obtained the marks? 60 to 65, it's like that. That is continuous frequency distribution. When we want to know the probability of obtaining any student marks at 70, then certain probability distributions came into existence. Those distributions which are dealing with the discrete data or discrete frequency distributions are called as or named as discrete probability distributions. For example, the two more frequently used probability distributions which are discrete in nature are binomial probability distribution and Poisson probability distributions. These are most frequently used and most common used probability distributions which are being used in real life situations. The another one where the data set is continuous, means continuous data we are trying to see 50 to 55, where the class intervals are being used, then means data is continuous in nature. And then the very most frequently used probability distribution is named as normal probability distribution. Normal probability distribution is, you can say, it's the backbone of the theory of statistics. Whatever the normal curve we discussed, that is also came out from this normal distribution. So this distribution is majority of the real life situations data, whether it is related to the marks of the students, whether it is related to the satisfaction level of the employees, whether it is related to the satisfaction level of the performance of the students, faculties, etc. All these follows normal probability curve, normal distribution. So the formula through which we can generate those probabilities, that formula is named as, or that function is named as normal probability density function for continuous probability distribution. So also we can call it probability density function. So for this, we need to develop this probability density function for all these values. Their probability densities need to be calculated. So for that, what we can do, so let me delete it first. Normal distribution is having these two parameters, mean and standard deviation. Those can be utilized. If we click here, you can say, 1 second. This is A, B, C, D, E. This is cell number E1. This is cell number E2. So we have this command norm.dist start bracket. Oh, let me create it here again. Equals to norm.dist NORM. Whether we are going to use, you can say, the capital words or small words, it's independent of that, the alphabets. So norm.dist, click on that. When we are clicking on this function of this, it will ask you the value of X, mean, standard deviation, cumulative. This E2 is the cell which we want to represent as this. So we will select this E2 here. So this X is, these are values of X, comma, it will ask us about the mean of this data. So mean is 85. So either you can type 85 or select this particular cell. So C5 is this cell. We selected this. Now, if we select this C5, then automatically what will happen when we pull it down, let me do it, then I will show you, you will understand. So C5, then it is going to ask you standard deviation. What is your standard deviation? So select this standard deviation 11. I had intentionally I selected this 11 so that the proper bell-shaped curve shape can be obtained. That's why. Comma. Then it is going to ask you about true or false. Two things are being asked. Cumulative. In cumulative, we can write here false. Cumulative distribution function, probability mass function. We want only the probability mass function values to be generated. That's why here we need to type false. If instead of false we will type true, then what will happen? The cumulative frequencies, cumulative probabilities will be calculated. What are cumulative probabilities? For example, here the probability is 0.1, here maybe 0.2, here maybe 0.3. So here the same probability will be there. Here this probability and this probability will be added. That will be here. And here all these three probabilities will be added. Those are the cumulation of the probabilities will be done, just like cumulative frequency distribution. So we typed here false and then we pressed enter. So this probability is being generated for this value. Now for the further one, what we can do after selecting this particular cell where we had just obtained this, pull it down. We will click on the on this right hand side bottom of this particular cell and put our left mouse click on it and pull it down. So automatically what will happen? Different probabilities will be calculated. Now you might have observed the first one is there. The second one is this some error is being reflected. Here some another probability will be calculated. Here some another probability will be calculated. Now why it happened? If you will see here, when we clicking on this, the function is being reflected here on the topmost side. It is being said that E2, C5, C6 false. E2 ये वाला value है. C2, C5 ये वाला value है. C6 this value is there. So this value is being calculated. Now click on this. Here it was C5, C6. Here it is E3. E3 means this 52 is being considered. C6 means this value is being considered as mean. C7 means this blank value is there at the place of C7. That's why this number is happened. So we have a solution for that purpose. Excel is providing one in the same manner. If we are further proceeding, we will find that C7, C8, C8, C9, C9, C10 like that. So we can fix these values 85 and 11, keep them constant as we assume that for this particular distribution, for this particular data, the mean and standard deviations are fixed. So mean and standard deviations are fixed. So we also want to make them fixed here. One thing, instead of this C5 and C6, we can type these values 85 and 11. It will solve our purpose. Another thing, what we can do, this C to fix this particular cell so that it will not proceed further. We need to put dollar signs before C and after C. Before C and after C dollar sign is being fixed. It means ये cell हमेशा यही selected रहेगा. आगे further ऊपर नीचे move नहीं करेगा. In the same manner for this C6, the standard deviation also we want to keep as it is. So this, comma, this, and then click OK. Now again pull it down or double click on this. It will calculate the probabilities. So all the probability densities are being calculated in this manner. So these are different of these probabilities. So now I hope it is clear to you how these probability densities are being created and why these are required, because we want to draw the normal probability curve. So now let's come to draw that normal curve. So for that purpose, we need to click on insert and line chart. Click on the line chart. And then here it will ask us to select data. Here we need to select data from the menu bar. When you click on this select data, it will ask the data and then add the series name X, that is marks, and series values are these data. Okay, and then add it. Okay, sorry, just let me repeat it again. I selected the wrong data here. So I'm repeating the entire procedure again. So insert line chart and then select data. In this one, add one, select the series name as this probability density, and then select the data. Then below this data where these probability densities are being selected, and this okay, and then okay. When we do okay, then again we need to do the edit. Horizontal axis means that horizontal one. This one we selected for that vertical one. Based on these probabilities, the curve will come out. Then for this horizontal axis labels, click on this edit, and then select the data. जो हमारे मार्क्स वाला डाटा है वो मार्क्स वाला डाटा हमने यहाँ पे सिलेक्ट किया. Then click OK. Okay. And now this normal curve is here with us. ये पुराने वाला था. Let me remove it. So this is our normal curve. We draw this normal curve. Now further we want to specify something in this one. So here we can do the editing. This is, you can say, the marks distribution. And what it is, variable X is being used for this one. And you can say in terms of statistics, you can write that X is normally distributed. N stands for that normally distributed. And it is, you can say, the mean was 85 and standard deviation as 11, close the bracket. So it is being reflected like this. We can do the editing. Now further what we can do, we can click here. Here the axes are there, axis titles we want to give. We can select on that. Labels on this, if we want that every dot point on this need to become, then we can click on this data labels. It will come here. Then data table, error bar can also be, error bar is nothing but mean plus minus standard deviation with respect to each of these points. Mean plus minus standard deviation. What does mean plus minus standard deviation? Means 50 marks or around 50 marks. Maybe the marks may be obtained by 3, 4, 5 students. Then within that range, that mean and standard deviation will be calculated, and then this uh, error bar reflect those things. These error bar reflect those things. Then trend line, then legends can also be specified. For example, this is indicating that probability distribution. The axis title can be given as this represents the marks. And axis title, these are the probability density. So for the color filling and all those things can also be done in this one. So this is our normal curve. So normal curve, how we can draw the normal curve using this particular, with the help of this Excel, it can be drawn easily. And it will assist us to further decide. It's very rare we will get that perfect normal curve, but we can obtain it. Sometimes what happens when data is not normally distributed, maybe different shapes are coming out. So what we try to do, we will try to take the transportation means sometimes what happen, for example, in real life, sometimes we are visiting to doctors with our elders and they are saying that inka hawa pani change karna padega, means shift them to some other place so that they can feel better. The environment can heal them and automatically then come back after 5, 7 days, 10 days, they will feel better with respect to their health aspects. So we take the transpose when some data is not normally distributed and our situation is something like that, normal distribution is must for that. Then we take the transformations of the data. Transformation means we will change the space. Sometimes it's very much difficult to find the solutions in the same space. So we change the space by taking the transpose and we get the solution there. And after getting that solution, we will again take the inverse transpose and we will come back to the real space. And so usually those log transformations, Laplace transformations, different kinds of transformations are there. Those can be utilized to take the data into original to some some of that particular transposition different space, and then again take the inverse transpose after getting the solution of that. That can be implemented, and it plays very well in many of the situations. So anyone have any question on this particular? You can say the draw of this normal curve with the help of Excel. Then okay, then we'll proceed further. Let's discuss something about this. Let's discuss on this Excel itself. Sorry. So the same Excel sheet we are proceeding with. Let me take this data and put it on some other sheet here. One more thing we can do, sometimes for the understanding purpose only, we need certain data points. So Excel provides us, there are some commands through which we can develop random data. We can develop random data between certain numbers. For example, let's say y is another variable, and it depends the marks in subject 2. And just for the sake we want to play with the data, so we want to develop some random data, that the question paper of 100 marks, and we want to see that there are 50, 20, 30, 100 students are there. We want to generate their data just like that. So one command can be used to develop random data, equal to RAND, rand between. When we type this rand between, means we are developing random data. So rand between, minimum marks, let's say the 40, maximum marks, you can say the 98. Close the bracket and press OK. So one number is being developed, 55. This is a random number developed between 40 to 98. Every time this number will change. So we'll pull it down. So random data is being generated here. So what command we used? We command which is already inbuilt command in Excel. That command is rand between. The command is rand between, RAND, rand between. So as it is directly, we should not perform any kind of function on this one. What we should do, we should copy it and we should paste it by doing right click. Because if we'll paste it like this, it will again rechange. Values will be changed. So we need to paste it as values. Only paste it as values. So only values need to be pasted, so that these values will not change. Earlier you can say, whenever we are clicking somewhere here, these values are going to be changed. So 40, earlier it was 55, now it is 41. But when we copy and paste it somewhere else, then the value will remain fixed. Because we didn't copy the function, we just copy the value, pasted the values here on. Now, there are some inbuilt functions in Excel for data analysis. Mean, standard deviation, etc. Those things can be calculated. And there is one analysis tool pack in Excel, which is majority of the times that will be in inactivated mode. So we need to activate that. So how to activate that Excel data analysis tool pack? For that purpose, we need to click on this file, click on file, and then search out their options. Usually in this particular, I think I'm using this Excel 16 version. Maybe some old versions are there. Under that file itself, I'm again repeating, click on file, then search some options. It may be here, or sometimes it may be here in some old and previous versions. Then click on options. When we click on option, one small window will appear in front of us. I hope it is visible to you, this small window which is appeared here. Now here on the right hand side bottom, when we are moving, it is written journal, formulas, proofing, save, language, advanced, customized, quick access toolbar, add-ins. This add-ins, click on this add-ins and we will find that different names of the applications. There are two modes will be there. One is active applications, one is inactive applications. Two things are being classified here. Active applications, inactive applications, and also disabled applications. So we need to see that whether this analysis tool pack is activated in our Excel, which is installed in our systems or not. If it is not installed, then it will be under this inactive applications. Then what we need to do, we need to select that analysis tool pack and then come to here in this bottom, that is manage Excel add-ins, click on go. When we click on go, it will ask us add-in available. These are the whatever Excel is being installed in our systems, these different add-ins are available. Means we can add these in our toolbar for routine purposes. So select the appropriate one. We have this analysis tool pack, then click OK. Within seconds, maybe hardly it may take 1 minute, the toolbar will be activated in our Excel. Now where we can that analysis tool pack we can find? For that, we need to click on this data. Now we clicked on the data, then look at the very much right hand side. हमने एनालिसिस टूल पैक डाटा एनालिसिस टूल पैक को एक्टिवेट किया. देन कहां पे मिलेगा एनालिसिस टूल पैक, कैसे निकाला? फर्स्ट वी विल गो टू दिस फाइल ऑप्शंस and here we'll click on this add-ins, then analysis tool pack. If it is activated, then you can by default it is activated in my system, but if you need to activate it, it will be under this inactive application in your system. So then click on this analysis tool pack and click on go. It will ask these add-ins are available. Which one you would you like to activate in your system? Then click OK. And then where we can find it, click on this data in the menu bar, file, home, insert, page layout, formula, data is there. On the very much right hand side, data analysis tool pack is activated. Now to see what kind of functions are there in this one, click on this and these different functions, analysis tool pack, these different things are there. One is ANOVA, single factor, two factor with replication. Yes, it is limited, but it's not all the things, but some major things are here. ANOVA factor analysis, correlation, covariance, descriptive statistics, smooth frequencies, app test, Fourier analysis, histogram, moving average, random number generation, rank regression, sampling, t-test, t-test ki 2-3 applications are there, z-test, etc. I hope it is clear to you how this function can be activated. Now, let's say this is our variable and we want to do the descriptive analysis. We want to perform the descriptive analysis of this one. Now, click on analyze and select this descriptive statistics. It is going to ask us the input range. Input range, select this, all these values including the column heading, including the heading of this. So we selected. Then it is going to ask us group whether the data is grouped by columns and rows. Our data is grouped by columns. In vertical form, the data is being column F is having our data. So it by default it is columns because usually we prefer to represent our data in columns. But if somehow that data is represented in rows, then we can select rows as well. Then it is going to ask labels in the first row. क्या आपके पास आपने first row में label दिया है? Yes, we have label. That is the name of the variable X. The variable name is Y. In bracket, we have mentioned that marks of subject 2. Then it is going to ask you whether where you want the output, whether you want to specify the output range here. Then you can click here and we can select the output range. Then new worksheet, let it be new worksheet. Then what you want, summary statistics, confidence level of mean, kth largest, select all of them. Or maybe if you feel confused, then let's first select only the summary statistics. We'll proceed further. Then click OK. So the new worksheet is being created automatically with the output. So let's see this. This is our output, which is being given by this Excel. Let's make it a little bit more presentable. Make them bold. That table, and you can say it is. So now you can see the output is there within second. Now, what kind of output is as represented? The mean of that data is being given, is calculated, the standard error, the median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum value of the data, maximum value of the data, sum of the values, and total count. So this is summary statistics, or we can call it descriptive statistics. But what these descriptive statistics are? So for that, I'm going to proceed to discuss some theoretical aspects of these descriptive statistics, because after deciding collecting our data, the first thing what we do, we want to understand. We have 10 variables. Out of those, all those 10 variables are having 150, 200, 500, 5,000 values are there. It's very much difficult to see uh, with our eyes and to try to get something fruitful out of that. So we need to perform descriptive analysis so that the data can give us better results. We can have data can by applying this summary statistics or descriptive statistics, we can have a better understanding of that data. So for that purpose, some theory, some concepts need to be discussed. So I'm proceeding with that. So central tendencies, descriptive measures. Yes. So just wait a second. Let me descriptive statistics. I hope the slide is visible to you all. The title is descriptive statistics.
Yes, sir.
Thank you, ma'am. So as the name, the first thing, if we know about how to add, how to subtract, how to multiply, how to divide, I hope everyone is very much comfortable with addition, multiplication, division, etc. So then you can easily understand these statistics. There is these four operations need to be performed. If manually we are doing nowadays, the softwares or not other softwares, Excel, if we are able to command that Excel is also so much powerful. It can provide us a very good good data analysis. You can say through this we can do that. So descriptive statistics. As statistics, we know that we discussed statistics is having four things majorly. It can be a science, it can be an art. Both the things are there. So data collection, data presentation, data analysis, and data interpretation. So majorly three things: collection, presentation, and analysis. Interpretations are individual choice, how he or she is going to interpret the data with respect to in line with his or her specialization. So one major thing where the statistics is being divided to two things: descriptive statistics and inferential statistics. So descriptive statistics is which can used to describe the distributions. Distribution means data set. The techniques which are used to understand to describe the data set. So the dictionary meaning of this descriptive is we want to describe. So the same thing is there in this one. So these four measures, descriptive measures are there in the theory of statistics: measures of central tendencies, measures of dispersion, skewness, and kurtosis. Out of these four, the first two are used maximum number of times. measures of central tendencies and dispersion. I hope you are aware about that mean, median mode, standard deviation, etc. Majority of the times, mean and standard deviations are more than sufficient. But if we want to understand the data in a much better way, then all these four measures are more than sufficient to understand the data. Now, conceptually, if we can say measures of central tendencies, the central tendencies, they tells us, they gives us a single value, whether our data set is having 100 values, 5,000 values, 10,000 values. Through these measures of central tendency, we can get a single value. And with the help of that single value, we can represent that entire data set. So it is a single value is going to represent the entire data set. That is measures of central tendency. But then why these measures of dispersion are required? There may be two or more than two data sets. They may have the same values, same central values. Then how we can compare them, how we can differentiate them, then it will be difficult for us. Then we can study the variation within the data sets. How much data values are varying from their central part. Central part may be mean, median, mode. Usually mean is being preferred. The measures of dispersion or measures of variation. So measures of dispersion or variation tells us the variation, standard variation inside the data set from their central part. So usually the variation where the variation is less, that data set may be more consistent, more good. And the data set where you can say the variation is more, that data set may not be more consistent, may not be more homogeneous. So that is the purpose of the variation. It makes us understand how much variation is there. For example, two faculties are there. They are teaching the same subject to the same kind of students. Let's say two sections are there, section A, section B. Section A belongs to faculty X, section B belongs to faculty Y. And the average marks of both the sections after the interim examinations are coming same. Let's say it's 70 for section A, 70 for section B, or maybe 71, almost same. So it's difficult to see the performance of that faculty, or maybe some another guy, the evaluator, or maybe the expert who has discussed them. Then what we can do, we can try to find the variation or dispersion. Where the variation is less, then we can say yes, X is good as compared to Y, if the significant difference is there in the variation. So variation tells us how much the data sets, data values are varying from their central part. That is variation or dispersion. Its purpose is to see the variability inside the data as well as to check the reliability of the measures of central tendencies. Then why these two more measures are required? Skewness. Measure of variation or dispersion only can tell us how much variation is there, but it will never tell us what is the direction of that variation. Direction of the variation means whether the variation is more towards the below the mean, below the central part, or above the central part. For that purpose, we need to whether the data is symmetrical or not, or symmetrical means normal or not. Then we need to study these measures of skewness. So measures of skewness are measures of symmetry of the data. Symmetry means, for example, my hands. My both hands are almost same, left hand as well as right hand. My hands are symmetrical, my head, and it check the shape of the normal car, like that. So left hand side may be utna hi hai, right hand side may be utna hi hai. If our data set are having 100 values and central part is there, then almost 50% values are below the mean, almost 50% values are above the mean. That is symmetrical. Whether the data is symmetrical or not, if it is more peak on the right hand side towards the above the mean, then it is skewed distribution. It is below the mean, then again it is a skewed distribution. Skewed means two types of skewnesses are there: positive skewness and negative skewness. You will see how those things can be identified. Then measures of kurtosis. Measures of kurtosis are those measures which tells us about the peakedness of the normal curve, peakedness of the curve of the data, peakedness of the distribution of data set. Whether the curve is coming as more peaks than normal curve. More peak means all the values are very near to each other. Tails are smaller, and maybe values are very near to each other with the central part. And one is normal curve or mesokurtic, means the curve is just like normal curve. Another one is the curve which is more flatter than the normal curve. Normal curve is like this, it is coming like this. Means on the top, almost a straight line can be drawn. So these four measures are more than sufficient to describe the characteristics of any kind of data set. So briefly, I will discuss and go through with them. We can also call them summary statistics as well. And sometimes the exploration when need to be done, we want to explore the different variables, different data set, then these summary statistics can be utilized. Under measures of central tendencies, the main objective of these central tendencies are to get a single value which can describe the entire data set, so the characteristics of the data set, and to facilitate comparison among two or more than two data sets. Before proceeding for, let's discuss this. There are different measures of central tendencies are there. One is simple arithmetic mean, or we can call it mean. One is geometric mean, one is harmonic mean. Geometric mean and harmonic mean are for some specific purposes. Then median and mode. Mean, median, and mode, harmonic mean and geometric mean. Then weighted arithmetic mean is also there. So out of these, majorly we focused on these three: mean, median, and mode. So I'm not going into inside this formulation. There are some shortcut methods and some direct methods are also there for manual calculations. But the major thing is here, we need to identify whether for my data set, because mean, median, mode, if we are considering these three, all these three provides the central part of the data set. But for my data set, which value, either mean or median or mode, which one is best suited to my data? It's our responsibility being a researcher. We need to identify which measure of central tendency is a good representative for my data, so that only that need to be utilized. So how we can identify that? So there are certain, you can say, the characteristics of a good average, which we want that being a human, we want that a good measure of central tendency should follow all these. So what are these? The first two, three are very much simple. It should be easy to understand. We know what is mean, median, and mode. All are easy to understand. Should be simple to compute. We can calculate them. Simple formulas are there. And nowadays, computation is done by the software. So it's almost very, very simple. Then third thing, it should be based on all the observations. Because when we have our data, we feel that all the observations of the data are equally important for us. So one major thing, whether the technique which we are going to use, whether it is measures of central tendency or dispersion, whether it is using all the observations of the data set or not, then we need to see that it should be rigidly defined. A good measure of central tendency and dispersion should be strongly rigidly defined. For example, mean. How we can calculate mean? We can add all the values and divide by total number of observation in the data set. So whether the data belongs to social science, whether data belongs to food science, whether data belongs to space science, whether data belongs to engineering, the formula will remain same. इसमें कोई change नहीं होगा. Whether it is shortcut formula or maybe the small formula will remain same. That is the rigidly defined. Then it should have sampling stability. Sampling stability, there are two words came now, the sampling and stability. Stability means fix. ये पेन यहाँ रखा है, बोतल यहाँ रखी है, तो बोतल यहाँ रखी है, फिक्स है, स्टेबल है. Sampling. What is sampling? Sampling is selection of certain samples from the population. And what is population? Populations, with respect to my objective, all the things which are directly related to my objective will constitute my population. For example, if I want to conduct some kind of study on the masalas which are available in the market, maybe some kind of testing need to be done. Then all the masala packets, brand, different, whatever kind of brand it is, whether it is sold open, that constitute my population. And within a region, maybe in NCR, maybe in Haryana, maybe in Punjab, maybe in Kerala, maybe in Tamil Nadu, that region need to be specified, or maybe the entire country. So selection of those samples from the population, the procedure through which we are going to select that is called sampling. And there are two broad categorization. There are different techniques of sampling, two broad classification of that. One is random sampling, one is non-random sampling. Random sampling is also called probability sampling, and non-random sampling is also called non-probability sampling. So random means where no biasness is required, no biasness need to be done. Then simple random sampling, multi-stage random sampling, cluster random sampling. There are different techniques of those random sampling. We can, based on our requirement, we can select appropriate one. Then another one, it should be capable for further algebraic treatment. Then means after calculating the measure of central tendency, we want that when we are going to calculate some higher level techniques, maybe regression, maybe correlation we want to perform, maybe t-test, maybe z-test, maybe ANOVA, then वो उसके अंदर भी use हो, that we are expecting. Then it should not be unduly affected by the presence of extreme values. Now extreme values. What are extreme values? Extreme values are, these are not the smallest value of the data set and not the largest value of the data set. Extreme values are which are very much away from the majority group of the data. For example, in PhD class, when we are taking the course for classes, usually sometimes what happens, some senior guys are also interested to do the PhD. So they may be in their 40s, they may be in their 50s, and they are still interested to do higher studies. So otherwise the class average age of the class may be around 25, maximum 27, 30 around. So when a guy who is aged as 50 years and he's enrolled himself in the class, so what will happen to the class? The average class of average that 50 will be treated as extreme value. Because what will happen with this extreme value, when we are going to calculate mean, then the mean run towards that extreme observation. Or we can say the arithmetic mean attracts towards extreme values. Or another term we can say the mean loves extreme observations. तो mean उनकी तरफ भाग जाता है. So what will happen? Maybe only that value which is extreme, maybe on lower side or maybe on the highest side. Mean is running towards that, and we observe that except that value, no other value is above mean, and all other values are below the mean. So in that situation, arithmetic mean should not be utilized. Arithmetic mean should not be utilized, although the arithmetic mean is based on all the observations of the data. Although the arithmetic mean is based on all the observations of the data, and arithmetic mean is having maximum sampling stability as compared to all other measures of central tendencies. Now, what is this sampling stability? Let's say we have one population, and from population we are drawing 4 or 5 samples. Then what we are expecting from our these descriptive measures, that specifically the measures of central tendencies, we expect that as the same procedure is being adopted to select the samples from the same population, so all the samples should reflect almost same kind of sample statistics. Statistics means the sample mean लगभग सबका same होना चाहिए. So except mean, all other measures are not so much stable. Mean is much more stable to all of them. Sample 1 is having some mean, sample 2, sample 3, sample 4. So based on these criteria or characteristics of good average, we can decide which measure is best suited to my data. Usually mean जाता है, but यदि आपके data set के अंदर largest values हो, extreme values हो, तो mean को आपको avoid करना होगा. यदि आपका data set तो यदि आपके डाटा सेट में एक्सट्रीम वैल्यूज हो तो मीन को अवॉइड करेंगे, देन वी कैन शिफ्ट टू मीडियन और मोड. मीडियन क्या करता है? पूरे डाटा सेट को 2 पार्ट्स में डिवाइड करता है आफ्टर अरेंजिंग द डाटा इन असेंडिंग एंड डिसेंडिंग ऑर्डर, एंड देन वी लोकेट द ओनली द सिलेक्टेड पोर्शन, the middle 1 or 2 observations. It depends on the even number of observations or odd number of observations. So median और mode आपका कभी भी 100% observations के बेस पे नहीं होता. वो एक स्पेसिफिक लोकेशन को आइडेंटिफाई करता है और उसके बेस पे आपको होता है, उसके अंदर सारी ऑब्जर्वेशंस को यूज नहीं किया जाता. मोड क्या होता है? मोड आपका मेजोरिटी, जहां पे मेजोरिटी बल्क होगा वो आपका मॉडल क्लास होगा. कुछ डेटा सेट्स में तो इट्स वेरी मच डिफिकल्ट टू लोकेट द मॉडल. कुछ डेटा सेट्स के अंदर 2 मोड होते हैं, 3 मोड्स, 4 मोड्स, इट डिपेंड्स. बाई मॉडल मल्टी मॉडल डिस्ट्रीब्यूशंस कैन केम आउट. So by looking at these, we need to decide which measure of central tendency is best suited for our data set. So the first thing is measures of central tendencies. And also one more thing, that there is a relationship between these mean, median, and mode. Usually in competitive exams, maybe nets, gate, etc. Sometimes these questions can be found in the examination. That mode equals to 3 times median minus 2 mean. So this relationship can also be used sometimes, because sometimes it's out of all these, mode is ill defined. मोड के निकालने के डिफरेंट डिफरेंट तरीके हैं. एक बार तो सिंपल निकल जाता है, यदि वो नहीं होता तो दूसरा तरीका अडॉप्ट कर लेते हैं, दूसरा नहीं होता तो थर्ड वे वी कैन ट्राई टू अडॉप्ट. बट समटाइम्स आफ्टर यूटिलाइजिंग ऑल ऑफ देम we still fail to find the mode. So mode is ill defined. Then what we do, we find median and mode, median and mean, and then by utilizing this particular relationship, we can find the mode of the distribution or the data set. So this is about measures of central tendency. Then quickly we will go through about those measures of dispersion as well. Measures of dispersion and then measures of skewness and kurtosis. So let me share with you that the quick idea about these measures of dispersion. I hope the slide is visible to you about these measures of dispersion or variation. So in measures of dispersion, there are, in measures of dispersion, there are, the main purpose of these measures of dispersions are to determine the reliability of the average, whether the average, if the variation is less, then the average of the data set is more reliable. Means the majority of the that average is representing the all the data set. If variation is more, then variable reliability will decrease. Average reliability will be decreased. And if we know that data is having certain variation, then we can control that variability. We can take some necessary actions to remove that, to minimize that variability, because no one wants that variability will be there, but variability is integral part. Then to compare two or more than two data sets with respect to variability, and to facilitate other statistical measures like correlation, regression, t-test, f-test, etc. There these can be utilized. So variation or dispersion is the degree to which data tends to spread about the central part of the data set. Measures of dispersion are those techniques which can be utilized to calculate that variation. So there are these 4 measures of variations, and one is also there. Usually it is used in that econometrics, that is called the graphical way, that is called the Lorentz curve. The range, interquartile range, average deviation, and standard deviation. And the 5th one, which is very much specific purpose, that is called Lorentz curve. So range is based on two observations only, the largest value of the data set and the smallest value of the data set. So before proceeding further, the measures of variation are also, there are two types of measures of variation in that. One is called absolute measures of variation and one is called relative measures of variation. What is this absolute and relative? Absolute measures of variations are those where, for example, the data set, it belongs to us, it is in kilograms. The unit of the data is kilograms. The final answer which we are getting of this variation, that is, the answer is also coming in kilograms. Then that is called the absolute measure. कि जिस original data, the original unit जो data set की given है, उसी के अंदर आपका measure of variation आता है. That is called measures of absolute measure of variation. The second one is relative measure, or we can call it coefficient of variations. Coefficient of variation means a unitless value. Means इसका कोई यूनिट नहीं होता. फॉर्मूला कुछ इस तरह का बनता है कि सारा यूनिट कैंसिल हो जाता है. So here, by utilizing this coefficient of variation or relative measure, we can compare 2 or more than 2 data sets with respect to variability if they are not in the same statistical unit. For example, one data is given in quintals, one data is in tons, one data in grams. So the variability in all those 3 can be seen directly by calculating these relative measures or coefficient of variations. The range, the largest value of the data set and the smallest value of the data set can be seen. It is the simplest one. इसका use कहाँ किया जाता है? Usually the quick idea about the variation. there it can be utilized. Fluctuations in share market, weather forecast, maximum temperature कितना रहेगा दिन का, evening का कितना, शाम का कितना रहेगा, वो सारा चीजें quality control aspect में भी. Then interquartile range आता है, or based on this we can find this quartile deviation. It is based on the 50% observation of the data set. The entire data is divided into four things after arranging the data in ascending and descending order. Initial 25%, next 25, 25, 50, 75 and 100%. So total three quartiles are there as to divide the data set into 4 equal parts. Quartiles ignore that 50% observations, the initial 25 and the last 25% observations. So if we feel that the initial 25% observation and the last 25% observations are not necessary or not so much effective, then we can go for these quartile deviations. Then when we have this mean absolute deviation, it is being calculated by taking the modulus of, it can be taken from mean as well as from median. Usually it gives good results when it is taken from the deviations are taken from the median. And then modulus, because negative signs are not useful here when we are doing that. So there are different situations where negative, when some values are coming below 0, they do not have any significance. Or sometimes whether it is on right hand side or +3 or -3, that doesn't make any sense, or means both are representing the same thing, then these can be preferred. But the most widely used measure of central tendency, measures of dispersion, is standard deviation, because it follows majority of the characteristics of a good measure of dispersion or variation. It is just the variation change in that one. The formula mean absolute deviation में हमने क्या किया था, यहाँ पे मॉड्यूलस था, यहाँ पे हमने क्या किया, यहाँ पे हमने इसका स्क्वायर किया. क्यों किया? ताकि नेगेटिव साइंस को हम नेगलिफाई कर सकें. एंड देन स्क्वायर के इफेक्ट को कम करने के लिए यहाँ पे स्क्वायर रूट ले लिया. जो स्क्वायर किया हमने उसके इफेक्ट को मिनिमाइज और रिड्यूस रिमूव करने के लिए वी टेकन द स्क्वायर रूट. सो सिग्मा इज द सिंबल फॉर standard deviation. Sigma square is variance. Out of all these measures of central tendencies, and this is coefficient of variation. In research papers, you will find that the CV, coefficient of variation, is being used. It is nothing but it is a relative measure of variation based on this standard deviation. It is standard deviation divides by mean of the data. We can find the coefficient of variation. So it's a unitless value. We can proceed it in any way with this. So, and then there is some relationship between them as well. So the most frequently used measures of central tendency and dispersion are mean and standard deviation. There are reasons for that. The initially we discussed of those 5 7s, both of them are having more stability. Both of them are based on all the observations of the data set. And both of them are further used for higher level statistical techniques. These three major reasons are there. But when we should avoid them when the data set is having you can say the extreme values present, means very large values and very small values in the data are available present in the data set, then we should avoid this. Another thing, when for example, if we have a continuous frequency distribution, if class intervals, means size of the class, like 5 to 10, 10 to 15, these are the homogeneous class intervals. When one class is 5 to 10, another one is 10 to 30, another one is 30 to 40. When class intervals or size of the classes are unequal, then we should not proceed with this. या तो आप डाटा को पहले सही कीजिए तब प्रोसीड कीजिए, अदरवाइज ये आपको गलत आंसर्स देंगे. Then measures of skewness and kurtosis. These are usually the measures of shape of the distribution. Measures of central tendencies dispersion never tells us about the direction of that variation. कि variation आपका किस side में है. For that, this skewness can be used. Skewness and kurtosis. Both of these are measures of shape. They represent the skewness bell-shaped. Bell-shaped curve, we can call it symmetrical curve, or we can call it normal curve. It's same. If we are deviating from that normal curve or bell-shaped curve or symmetrical curve, it means our data is not symmetrical. Now, what is the meaning of this symmetrical? let's see this. This in symmetrical curve or normal curve, we have assumption that mean, median, mode all are coinciding. This is a bell-shaped curve or normal curve. Whatever we prepared in that in the Excel, that was also a bell-shaped curve. It is having certain properties, certain characteristics that mean, median, mode all are same. Mean, median, mode all are same for this data. Approximately same. Exactly same milna reality में, real life में, that's very difficult. But approximately they are same. And if your data set is having 100 values, 100 observations, then almost 50% values are below this mean here in this side. And almost 50% values of the data set are above this mean, like this, on this area. And the total area under the normal curve, is 1. 1 means total probability is 100% from here to here. And 50% is below mean, 50% is above mean, means 0.5, 0.5. And there is one property that mean plus minus standard deviation. Mean plus minus standard deviation is here and here. I will show you in some other slides and then we will discuss at that time with you. Mean plus minus one single standard deviation. यदि किसी data set का mean plus minus standard deviation approximately 60, I think 68% observations are between these 2 points. Mean plus minus 2 times standard deviation, approximately 95% observations will fall between those 2 points. Mean plus minus 3 times standard deviations, 99.97% of the observations will fall between those 2 points. This is, you can see that roughly we can get the idea about that, whether the distribution of data is symmetrical or not. So if the data set is coming like this, means the curve of the data is, distribution of the data is coming like this. This is called negatively skewed. Why it is negatively skewed? Because the maximum peak is the mode. Median is a positional average. It will lie in the center of the data. आपकी जो 100 वैल्यूज है तो 50 से और 60 के बीच में, 45 से 55 के बीच में कहीं ना कहीं लाई करेगा. Mean is based on all the observations. What it indicates, this kind of curve, that data set is having some extreme observations. And what happens to when the data set is having some extreme observations, what happened to mean? Mean attracts towards them. So here some very small values are there. That's why mean is here. So the simple way, whether is positively skewed or negatively skewed, we can find that mean minus mode. Mean minus mode. As mode is higher, mean is smaller. So this kind of distribution is called negatively skewed distribution of the data set. And this kind of curve, mode, this is here your origin to here. These are different values of x, 2, 10, 20, 30, 40, 50 here. And these are their frequencies. And this data is came out like this. So here what is happening? The mode, again, extreme values are there towards the right hand side. So mean is attracting towards that. So again, mean minus mode is smaller than mean. So it is positively skewed distribution. So there are, you can say if mean, median, mode all are same, then we can say it is symmetrical distribution or bell-shaped distribution. If it is, they are negatively skewed, means mean is, mode is greater than mean, then the distribution is negatively skewed. If the mean is greater than the mode, then the distribution is positively skewed. So these three things are there in this skewness. It tells us about the direction of the variation. कि direction की central part से variation आपका left hand side की तरफ है या right hand side की तरफ है. या हम large data set को assume करते हैं कि वो normally रहे. Normal means skewness 0 हो. No skewness is there. And these are, you can say, the Pearson's some coefficients of skewness can be calculated like this: mean minus mode divides by standard deviation. This is Carl Pearson's skewness. This is Bowley's skewness. This is based on quartiles. This is Kelly's skewness. It is based on percentiles. And this is normal curve or bell-shaped curve or symmetrical curve. This is negatively skewed. This is positively skewed. Now, what is kurtosis? Kurtosis is about the shape of the distribution. कि curve कैसा बनता है? 3 types of curves are there. One is called mesokurtic. Mesokurtic means just like normal curve. One is platykurtic, more flatter than the normal curve. One is leptokurtic, more peaked than the normal curve. It tells us about the peakedness. For example, this graph. This is indicating about leptokurtic, means the curve is more peaked than the normal curve. So what kind of interpretation we can make out of this? The values are very near to each other, near to their central part. कि सभी बच्चों के, यदि एग्जामिनेशन सिस्टम की बात करें, सभी बच्चों के मार्क्स लगभग एक जैसे आए हैं, 60 60 60 65 62 टू 60, तो ये भी अगेन क्वेश्चन मार्क लगता है. इन सर्टेन सिचुएशंस, इफ द पीक्स आर we are getting, then that may be very good. But in certain situations, the peaks are not treated as very good. The tails are running on these sides. This is platycardic. It is more flatter than your normal car. मीन्स यदि हम यहाँ पे कोई लाइन पास करें तो वो लगभग एक स्ट्रेट लाइन का फॉर्म ऑन द टॉप साइड ले लेगा. मेजॉरिटी ऑफ द पॉइंट्स विल बी वेरी वेरी नियर टू ईच अदर. मीन्स डेटा इज हैविंग मोर स्कैटरनेस, मोर वेरिएशन is indicates. This is mesocortic, just like the normal car. These four measures are more than sufficient to describe the characteristics of any kind of data set. Usually -3 to 3 के बीच में skewness lie करता है. यदि skewness 0 हो, coefficient of skewness, तो बहुत अच्छा है. 0 के आसपास है, नेगेटिव साइड प्लस साइड ऑलमोस्ट नॉर्मल की तरह ट्रीट किया जाता है. बट इट इज गोइंग बियॉन्ड -2 +2, देन इट इज नॉट गुड, नॉट ट्रीटेड एज गुड. It doesn't mean कि further measures further descriptive measures can also be calculated. We can calculate them. Usually what happens then when we are calculating for these measures of central tendency, it is nothing but that x minus x bar. This is called the first movement. The second movement is, if you will see the standard deviation formula, it is x minus x bar. न्यूमरेटर में क्या रहेगा आपका x minus x bar whole square. यदि आप skewness कैलकुलेट करते हैं तो न्यूमरेटर में रहेगा x minus x bar raised to power 3. यदि कर्टोसिस को हम डायरेक्टली कैलकुलेट करेंगे डेटा के साथ, it will have x minus x bar raised to power 4. So fourth movement is kurtosis, third movement is skewness. Fifth movement can also be calculated. X minus x bar raised to power 5, x minus x2 bar raised to power 6, up to infinity. But these four measures are more than sufficient to describe the characteristics of any kind of data set. And out of these four also, the first two, measures of central tendencies and measures of dispersion, are most frequently utilized by all the researchers. But if I suggest you, but if you guys are having more data, then you should proceed with all these. At least skewness तक तो आप जरूर जाएं. आपको आइडिया लगेगा कि मीन से ज्यादा की तरफ रेस्पॉन्स ज्यादा पॉजिटिव ज्यादा आए हैं, मीन के नीचे की तरफ रेस्पॉन्स ज्यादा आए हैं. वो आपको बहुत सारी चीजें उस डाटा के बारे में अंडरस्टैंड करने में बहुत अच्छी हेल्प, असिस्टेंस, मदद रहेगी आपको. So these are some descriptive measures. And now I'm again coming back to that Excel, which we calculated. We'll try to see. Yes, here it is. For this data, we did those calculations. We calculated the mean, the descriptive measures of this. Yes, these are here. So mean of the data is coming as 73. Median is 76, 75. So data is almost normal. The values are very near to each other. They are not 4. Standard deviation or variance, standard deviation is coming as 17. Sample variance is huge. Standard error. Standard error. Now, this is very important term. Let's understand what this standard error is. Usually what we try to do, being a researcher, we don't believe on one sample. So we try to collect one sample is having 10 observations, another sample we are drawing from the same population which is having 20 observations, 20 observations from there. Another sample we are having 15 observations. We try to see, draw more than one samples. But what statistician did, based on one sample we can rely. For that, they developed a technique named as standard error. It is nothing but standard deviation divides by square root of sample size. Standard deviation divides by, it is standard deviation divides by square root of n. ये standard error का formula बनता है. So if we have one sample, then we can utilize it. If this is the standard error which is already being calculated. If this is minimum, then our data set is good. Then there are some more laws of the statistics. One is law of large numbers. That law of large numbers, or one is, it is under the main theorem, that is law of statistical regularity. Statistical regularity, these laws indicates that if the samples are selected randomly, from the population and sample size is large enough, then we are almost sure that sample mean will be a very good representative of the population mean. Means जो भी हमने sample लिया है, यदि sample size बड़ा हो, sufficiently बड़ा हो, वो sufficiently हमें decide करते हैं, researcher को decide करना होता है. Sample size is sufficiently large and samples are being selected randomly from the population, then we are almost sure that our sample is having all the characteristics of the population. That is law of large numbers indicates. Then if you look here, the skewness is minus 1.4. Data is negatively skewed. It indicates, sorry, this is kurtosis. The skewness is minus 0. Towards negative side around 0.5. So it is almost near to the normal distribution. Kurtosis is negative, means it indicates about that peakedness and all those things. So this is about these descriptive measures. So whenever you have a data, the first thing you need to perform this descriptive measure, calculate all the descriptive measures and try to make the interpretation, try to understand what this data tells you. Then further we can proceed after that. Now, we broadly try to discuss about this. Let me again share this descriptive measures. Now let's see another technique which are named as correlation and regression. Correlation, simple correlation we will try to discuss. Simple correlation means where the variables, two or more than variables, we want to try to see the relationship between them. What kind of relationship they are having. And both the variables, maybe it is, for example, let's say X and Y. X may be the marks of the students. Y may be the time spent on studies. Or maybe the X is the advertisement, Y is sales. Or X may be demand, Y may be the sales or supply. X may be the demand, Y may be the price. But the variables, we assume that both the variables are not related to each other. And we want to see whether the variables are related to each other or not. So when two variables are involved, it is called simple linear correlation, simple correlation. And correlation coefficient is being used to see the relationship between the variables. Correlation coefficient tells us about the strength of linear relationship between two variables. We have partial correlation, means where more than two variables are involved. We want to keep one variable constant and we want to see the effect of remaining two, the relationship of two. We have multiple correlation coefficient where simultaneously we'll try to see the relationship of more than two variables. So how we can perform in Excel. Let's say we have some data. Let's develop some random data. Again, we are using the same command rand between. It is equals to, let's say 20 to 50. And in the same way, maybe we are developing the same here for this one. Maybe here it is 20 to 60. Just to see so how we can perform it in Excel. And let's say we have this data with us. So let's make it fixed so that otherwise it will change again and again. So it is fixed. We had copied and pasted it here. Now we want to find the correlation first. Let's parallelly find the regression as well. So click on data analysis toolpack is activated here, data analysis, and then come to correlation. Yes, here it is correlation. Double click on this correlation. It will ask us the input range. We select both the variables with their labels. The data is grouped in columns, labels in the first row, and click OK. Now the output is there with us. I hope you are able to see. This is the output. What this output is indicating, the variation between the relationship between the variables x and y, x and x, it is 1. Yes, when two variables are simultaneously, it is 1. Variable y and y, 1. Between x and y, it is coming as minus 0.47 or approx 0 minus 0.5, means variables are negatively correlated. Negatively correlated means correlation never tells us about cause and effect. Ki variable 1 is increasing, that's why variable y is increasing. It only tells us about the how much, what is the strength of relationship between the uh, between two variables. Its value for simple correlation coefficient, its values lies between -1 to 1. If the value is coming at 0 for correlation, that 0 indicates that variables are not at all related with each other. Variables के अंदर कोई relationship नहीं है. And if it is near to 0, it is whether it is positive or negative, it indicates the same thing. If the variable values are near to 1, +1 or -1, either. So if it is towards +1, value of correlation coefficient, that indicates that variables are highly correlated with each other. 0.8 and above, usually 0.8, 0.6, 0.7, 0.8, 0.9 are termed as very good correlation between the relationship between the variables. And the same means positive variation, a positive relationship between the variables. If the relationship correlation coefficient is coming as near to -1, let's say -8, it indicates the negative relationship between the variables. Negative relationship means if one variable is increasing, then another variable is decreasing. Positive relationship means, for example, 0.8. If one variable is increasing, then the another variable is decreasing. This is the indication of that. And whether we are putting the variable x first or y first, it doesn't mean, both are having the same meaning. For example, here it is coming as this. So this, the same value will also for x and y. So this is the correlation coefficient, the basic idea and the concept about this correlation coefficient. Then another one is for the same, we can say that regression. Let's try for that regression, how we can find the regression, and we'll try briefly about it in the discussion part. Then again, go to the data analysis. And here we have our regression, simple linear regression. Regression also, in regression, one variable can be treated as independent variable, one variable can be treated as dependent variable. For example, we feel that sales depends on price. So y may be the sales, x may be the price, or maybe vice versa, demand and supply. We can decide that thing. So cause and effect relationship can be established with the help of regression, simple linear regression. Simple linear regression. Linear regression, we can have multiple regression. Multiple regression means one variable is dependent. It depends on different independent variables. So let's calculate this. Input range for variable y we had selected here. Input range for x, we selected here variable x. Labels in the first row. New worksheets. We want to find the residuals. We want to see the standardized residuals. We want to see the residual plots, line fit plots, normal probability plots. ये सारे आपको indicate करके indication निकाल के देगा. Now click on, by default it will select the new worksheet. Let it be, click OK. So now these different outputs are coming. Let's discuss them. Regression is very powerful technique for forecasting, for prediction, or you can say this is the base of the modeling. If you want to do some kind of mathematical modeling, you can say statistical modeling or stochastic modeling, then regression is the best technique to initiate with. Other techniques also are also the based on this one, you can say. So the regression equation is y equals to a plus bx. Y equals to a plus bx. Y may be, you can say, the sales. X may be the price. So what is here? You can say multiple R by, 1 second. Here R is being calculated. R square is being calculated. Another important concept is this R square. What R square is? R square is nothing but it is the square of correlation coefficient. If R is 0.8, then R square will be 0.64. Just square that. That is R square. What R square tells? R square is called coefficient of determination. Coefficient of determination. It determines, for example, here these two variables x and y. We want to know कि what is the influence of price on the sales. कि जो हमारा variation, जो हमारा regression line आया है, let me write that regression line, then we will discuss about this R square as well. Then look at here, these coefficients. Intercept. In regression equation, y equals to a plus bx. A is called y-intercept. X, coefficient of x is this b. B is this. And I hope the regression, that plot is here. Yes, here is the plot. This is the line of fit which we obtained from this. Let's understand this. This is line of best fit. Means this kind of line is coming as, because the value of x is negative, means it indicates that if price, this is x values, price is 0, 10, 20, 30, 40. What it indicates, as the price increases, y is our sales. Y is our sales or demand. As price is increase, when price is, you can say this much. When price is around, you can say 23, 24, then the sales were 50 units approx. When prices are decreasing, price are increasing, price is approaching towards 50, the sales are decreased to approx 30. So this x value is negative. This b coefficient, the value of b is negative. It indicates that the slope is negative, means enhancement of one unit in another variable is going towards the negative side. So price depends on sales. No, sorry, sales depends on price. As price increases, sales are going down. This indicates that. This 67 A intercept. Let me draw another one to make it better understandable. Let's say this is X, this is Y. And let's say normally we are getting a line something like this. This is Y equals to this line. Not related to this example, just to make it understand in a layman's. Here it is your origin. Then here the increasing values of X, here the different values of Y are there. When let's say this is our line. So this is our line, linear line. Where it cut it the, where this y equals to a plus bx, the linear line cut the y axis here at this point. From here to here, you can say this is a. This is the value of a. It means that price बढ़े या कम हो, यदि ये ऐसा इंडिकेशन देता है, ये what this a value tells this. Price increase, whether price increase or decrease, इतना सेल्स रहेगा, इतना सेल्स आपके प्रोडक्ट का रहेगा. This indicates about this a intercept. This is called a intercept. Sorry, y. This is called y intercept, where this straight line y equals to a plus bx cut the vertical axis or y axis, that is called y intercept. Now b, for example, 1 unit change from here to here. यहाँ पे मान लीजिए 5 था, यहाँ पे आपका 8 रुपया हो गया सेल्स प्राइस का. तो what happens? what happens to the y when one unit change in x is being observed. So that is represented by b, that is slope, called slope. Slope indicates that rate of change. एक वेरिएबल में एक यूनिट चेंज होने के का क्या इफेक्ट पड़ता है आपका y वेरिएबल के ऊपर. Y means the dependent variable. Here variable y is dependent and we assume that the sales, that is variable y, depends on variable x, that is price. Here in this data also we can see that this is the almost the straight line which is coming like this, the best fitted line. ये डाउनफॉल में है, प्राइस बढ़ रहा है तो डिमांड आपके कम हो रही है. दिस इज प्रिडिक्टेड बाय, ये एस्टिमेटेड जो हमने किया है. दिस इज द मॉडल. सो a and b are those values. These are called regression constants. We can call them constants, arbitrary points, or as well as coefficients as well. So this is something about this regression. Then regression is also having bound to certain conditions that data should be normally distributed. The samples which we have selected, those samples are independent in nature, are independent. They are not depending on each other, and normality is being followed. And also that the variability is almost same in the populations. These are four assumptions are there. If those assumptions are satisfied, then we can proceed with that. The thing presently which I tried to show you, this is related to the qualitative data. We have there are 8 to 10 forms of regression: lasso regression, logical regression, this regression, log regression, etc. Whether data is qualitative, sometimes qualitative data is also there. There also can be regression, can also be utilized, but the different form will be there for that. And also in this one, these T statistics is also they are being used. This tells us about the significance, whether we had taken a sample, whether these values are applicable to the population as well. So for that, first I will try to discuss with you about the hypothesis testing procedure, because that's covered about our inferential statistics. 10 minutes. Give me that idea to. Try to briefly explain about the hypothesis testing procedure, and then I will try to show you something about this t-test and analysis of variance with the help of Excel. Please confirm, are you able to see this hypothesis testing slide? Hello, am I audible?
Yes, sir.
Okay, thank you.
Yes, sir, we can see.
So hypothesis testing. Till now we were discussing something about the descriptive statistics, briefly about that. Now the second form, you can say the where broad of the majority of the techniques are divided into these two: the inferential statistics and descriptive. Descriptive, we try to discuss something. Now the hypothesis testing procedure is under the part of that inferential statistics. What inferential statistics is? It tells us about that one population is there. One population is there, and
Let's say inferential statistics, let's say this is our population, and from this population we are drawing a sample. So whether the two things are there, one is parameter and one is statistics. One is parameter, one is statistic. So parameter represents the characteristics of population. Parameter represents the characteristics of population. And statistic represents the characteristics of sample. So what parameter is? Parameter can be mean of the population, can be median of the population, can be standard deviation of the population. Whatever the descriptive measures of the population are, they can be named as parameter of the population, parameters. So in statistics, parameter means they are representing the characteristics of the population. Characteristics means mean of the population, standard deviation of the population, or as per our desired thing. Then statistic. Statistics, it's statistic. Statistic represents the characteristics of sample. Statistic represents the characteristics of sample. So it means that characteristics represents the statistic represents the characteristics of sample. It indicates about the characteristics of sample. Sample mean, sample median, mode, as per our requirement, as per our data set requirement, those can be named as statistic. If the same thing is being calculated for the population, then those can be named as parameters. So hypothesis testing procedure. So there are there is a 5 to 7 steps procedure is there. Sometimes you can bind it into 5 steps, sometimes in 6, sometimes in 7. Everyone can decide that by their own. So whenever we have objective, that objective need to be subdivided into divided into sub objectives. Then sub objectives need to be, for each sub objective we need to identify certain hypotheses. The hypothesis which we want to test, which we want to evaluate, that is called null hypothesis. And if null hypothesis is not happening, then what may happen? That is the alternative portion of that. Alternative hypothesis, we need to identify null and alternative hypothesis in the first step. Then in second step, we need to determine the appropriate statistical test. Which statistical test need to be applied? Under what is the level of significance we should fix? What is the set of decision rule? Decision rule means how we can decide whether the null hypothesis may be accepted or not accepted. Then how to collect the data collection, analysis, and then finally the statistical conclusion based on that. So if you can see this slide, let me come to that example directly. Yes, we are discussing one of the example of one of the application of t-test. This example, this tells that there is a company named as Royal Tires. They are manufacturing a specific type of tires for tractors, and the company is claiming that under normal conditions, when they test it, the average life of the tires is coming as 40,000 kilometers. Means in one go, the 40,000 kilometers the tires will run. Now let's assume you as a retailer and you want to purchase those tires by investing 1 lakh, 1 crore, 2 crore rupees, so that you can run your own business. You want to test that claim, whether the manufacturing, whatever he is saying, that is okay or not. And for that purpose, you had requested it, or maybe you have purchased. It depends on you how you are able to manage with the vendor, with the manufacturer. You had selected randomly a sample of 8 tires, and you obtained certain results after that. Now you want to test the hypothesis that the average life of the tires is as per the standards which are being mentioned by the the tires company. So what we usually proceed with, there are these out of these 5, 6, 7 steps, the first 3 steps we need to fix first. Before data collection, we need to come to these first 3 steps. The first thing, we need to develop the null hypothesis. Now, what is null hypothesis? Hypothesis is an assumption about the population parameter. Here, the population parameter is mean. And null hypothesis means whatever the manufacturer is saying, whatever the owner is saying कि मेरे ट्रैक्टर का मेरा टायर जो मैंने बनाया है ये 40,000 किलोमीटर चलेगा, as it is we are accepting it. As it is we are accepting it, and we want to test the same thing. So that is that mu equals to 40,000 is indicating that the average life of the tire is 40,000 kilometers. We assume is as null hypothesis. Why it is null? Whatever the population is saying, whatever the manufacturer is saying, the same thing is being assumed. This is a tentative statement whose truth need to be tested critically. Then alternative hypothesis, as we do not have any doubt, then the alternatively it may be less than, it may be more than, the three options are there. Or it's not equal to means it is either less than or it is more than 40,000 kilometers. Either it is less than or more than 40,000 kilometers. So this we have decided. If the null hypothesis is like this, the null hypothesis is, alternative hypothesis is not equal to, it indicates, look at this. The alternative hypothesis is like this, not equal to, it indicates that both the sides, that either it may be less than 40,000 kilometers, it may be more than 40,000 kilometers. That indicates about that alternative hypothesis is like this. Means both the sides. ज़्यादा भी जा सकता है, कम भी हो सकता है. यदि only if it is only greater than or less than, then either on this side or on this side. Then the second step is we need to decide the level of significance. Now, what is this level of significance? It is denoted by alpha, or also it is called as type 1 error. As this is the total area, 40,000 किलोमीटर का जो हमने कहा कि हमारे सारे टायर्स 40,000 किलोमीटर ही रन करेंगे, ये सारा उसी को इंडिकेट करता है. When we are taking 5% level of significance, means whatever we assumed population mean as 40,000 kilometers. So it means that level of significance means that we are attaching a 5% means 0.05 probability with the null hypothesis that it may not true in reality. So 5% error chance we are considering. That 5% in two-tailed test is divided into two components. 5% means 50% of the 5% is on the right-hand side, 50% of the 5% is on left-hand side. And the total area under the normal curve is 1. So within this one is called 95% area. And these tails are indicating that 5% area. So 95% area is our acceptance region. And this 5% on both the sides are indicating our non-acceptance region, or non-acceptance of the null hypothesis. So the first step, the second step is level of significance. And who will decide about this level of significance? It's the responsibility of the researcher to attach this probability with the null hypothesis that null hypothesis which we assumed it may be wrong. Then the third thing, we need to understand which type of statistical test is applicable. Under inferential statistics, there is two broad categorization of statistical test. One is called parametric statistical test. Another one is called non-parametric statistical. Parametric statistical tests are those where we know about the population. Population के parameters के बारे में जहां हमें जानकारी होती है. Those tests are parametric tests. For example, in present situation, we know about the population mean. If we know about the population mean, it means we are dealing with the parametric statistics. Then next step, we need to see the sample size. If sample size is small sample size, as per the theory, it is decided, it is specified that if the sample size is less than 30, means 2 to 29, that sample is treated as small sample. If the sample size is greater than or equal to 30, that sample is treated as large samples. So under parametric, for small samples, t-tests is utilized. And for large samples, z-test is there. T-test and z-test are almost same. But for small samples can be used for the large samples as well. Sometimes you find that the sample size is around 70, 80, still t-test is being used. that is applicable, that can be utilized, because t-test behaves like z-test as sample size increases. But vice versa, z-test cannot be used for small samples. So after deciding these first three steps, we proceed with the data collection. So here, in this particular case, only one population is there, that one population of the tires, from where we had decided to select a random sample. So the name of the t-test application is test of hypothesis about population mean. Population mean need to be tested. And this is the population means which we have assumed. So this application and the formula for this application is this, that is t equals to x bar minus mu divides by s by square root of n. So then we collected the sample and the sample is available with us. Now 8 tires we have bought. Then we need to perform the experiment to see the shelf life, to see the life of those tires. There are two ways to perform that experiment. One, we can buy a tractor, 1, 2, 3 tractors, and install those tires in those tractors and ask the driver to run. It may take 3 years, it may take 5 months, 6 months to get the data. Another way, we can perform the lab experiments. We will make a structure like that where the tires can put under the same conditions based on which the manufacturer is claiming. The same conditions are being created in the lab scale and simulation is being lab scale, and the tires are run under the same conditions. And maybe in 10 days, 15 days, 1 month, we can get the data. So this is the data which we obtained. First tire, 35,000 kilometers, second tire, 38,000 kilometers, and so on. So this is the data under the variable x which we obtained, like this. Now, the next step of this hypothesis testing procedure, we need to do the data collection. Data collection is done. Now we need to analyze the data. For data analysis, whatever the formula is there for this particular application of t-test, this t-test, then this t-test x bar minus mu divides by s by square root of n. X bar is indicating sample mean, mu is indicating population mean, and small s is indicating this denominator is called standard error. The denominator is called standard error, which is nothing but standard deviation divided by square root of the sample size. So when we analyze this data, we find the mean as 39,750, population mean as 40,000, and standard deviation is coming as around 2,500 of the standard deviation. Sample size is 8. When we replaced all the values in this t statistic for this one sample t-test, we obtained the result as 0.28. Remember, in t-test and z-test, whether the calculated value, that is t value, this value is called t calculated value. Whether the value is plus or minus, it doesn't affect. If the value is coming as minus, take modulus and make it positive. Both are having same sense. On this side or on that side, both are having the same sense. So this value which is being obtained, this is called t calculated value. This value is called t calculated value. Now, we need to make decision about the acceptance or non-acceptance of null hypothesis. For that purpose, what we need to do, we need to see the table value. The table value which are being created by the statisticians based on the conditions of the t distribution. And what are those tables? One table is there that I will show you about this particular one. T table. Just 1 second. Let me show you the table. I hope the table is visible to you. These are statistical tables.
Yes, sir, we did.
Thank you. For t-test, you can say this is a statistical table for the t-test. Here, the structure of the table is like that. In the first two rows, the significance levels are being mentioned. Significance level means the probability which we have associated with the null hypothesis that it may not be right. And on the first column, there are degrees of freedom. In t-tests, there are n-1 degrees of freedom. Now, the concept of degrees of freedom is like that. As we assume that here in this situation that the average life is 40,000 kilometers. So population mean is somehow we assume 40,000 kilometers. So the same thing we are expecting from the sample as well. Whatever samples we will get, their average will come as 40,000 kilometers. So when we are saying that we have eight samples of size 8, then only 7 samples information need to be is required, because when we know in advance that mean of the sample x1 plus x2 plus x3 up to x8 divided by 8 equals to 40,000 kilometers, after those 8 values, only 7 values are required. 8 value can be determined automatically. That's the concept of the degrees of freedom, ki how much values we are able to choose freely independently without that condition which is being imposed due to the assumption of the population which we assumed as null hypothesis. So the degrees of freedom are n-1, that is 7, and it is the two-tailed test at 5% level of significance. This is 5% level of significance, and this is our statistical table as 2.365. This is the table value. Now this table value need to be compared with the table value need to be compared with the table value 2.365 need to be compared with the yes, the table value 2.36 was the table value. T calculated value is 0.28, which is less than the tabulated value. So null hypothesis may be accepted. It means the claim made by the manufacturer, that is 40,000 kilometers is the life of these tires, is okay. We can further decide to invest on this one. So in this way, this inferential statistics assist us. Now there are two more applications which are very much one more application which are more frequently utilized for these t-tests. I will directly perform that on the Excel. It is the name of the application is hypothesis testing about difference between two population means, or independent sample t-test. In this independent sample t-test, the two populations are involved and two samples are being drawn independently from population 1 and population 2. For example, two classes are there, let's say section A and section B, and we want to see the performance of those students who are in these classes, who are in these sections. Based on the marks based on the test conducted, both the populations of section A and section B are homogeneous, means they belongs to the same class, same group of students. Approx means all are doing BTech, all are doing MSc, like that. So two populations are involved. So let's generate some random data. Generate the random data for both. Let's say in our sample we have these values. This is independent sample t-test, which we are trying to discuss. So click on data. Here hypothesis is that both the populations, mean of this population equals to mean of this population. This hypothesis we are proceeding with, and we are taking a level of significance at 5%. And the sample data is available with us, and t-test, independent sample t-test is applicable because sample size is, it is number of pair of observations we have. You can say the 9 pair of observations are available, or sample A is having 9 observations, sample B is having, you can say 9 observations. Total, you can say the 18 observations are there. And data analysis, let's go for the t-test. Two sample assuming, there are two applications here in this t-test for this independent sample t-test. Two sample assuming equal variances, and t-test next one is two samples assuming unequal variances. We assume usually proceed with the equal variances. So double click on that. It is going to ask us about the range of the data. Variable 1 A, variable 2 is our B. Now labels are there in the first. Hypothesis mean difference. We need to give here value. We assume that both the sections are equally performed. So the difference in the average marks of section A and difference in the average marks of section B is 0. So now level of significance alpha is being, it is asked, by default it is 5. We can increase and decrease. Let it be by 5% level of significance and click on OK. So when we clicked on OK, we get this output. These initial values, these are the summary of this data, means section A column A sample, B sample data, the mean and variance of that thing. And this is pooled variance, means the joint variance of both of these, because we assumed. And this is our hypothesis, which we assume for the situation that hypothesized mean of both of these populations are same. And this is our mean statistics that come, the output which came out. What it tells, let's discuss. This is T statistics. This is called T calculated, which we the values of manual calculate karte hain. This value is being calculated. Excel give us whether the test is one-tailed, two-tailed, both things are being provided by us, and it provides us the two things. One is p-value and one is critical value. This is p-value, or we can call it significance value.
P-value what?
P-value or significance value. When we use softwares, automatically by default, this p-value is being provided to us, and we make the decision based on this by comparing it with the level of significance, which is here 5%. And this is our table value. Excel provide both of them. And this is our calculated value. And we need to compare it with this table value. Take the modulus, make it positive, it is 1.9. So T calculated value is less than the calculated value, less than the tabulated value, that is 2.11. So null hypothesis may be accepted in this case. And if you compare the p-value with the level of significance, here the decision rule is little bit different. If the p-value is greater than the alpha value is 0.05, then null hypothesis may be accepted. If the p-value is less than the alpha value, then null hypothesis may not be accepted. This is the decision rule for this. So this is our independent sample t-test, or you can say the hypothesis testing about difference between two population means. Now one more we can perform, the last one for today's session, that analysis of variance, one-way analysis of variance. Let's say we have three populations involved with us, x1, x2, x3, and we have certain values under this. Certain data is being collected. X2, X3. We want to perform here on this data one-way analysis of variance. One-way analysis of variance where we need to perform where t-test can work up to 2 populations involved. When more than 2 populations are involved, then we need to shift to analysis of variance technique. So again, we hypothesized that on average, all these populations, let's say this belongs to population 1, population 2, and population 3. All these populations are same on average. So let's perform one-way ANOVA on this. One-way ANOVA without replication, ANOVA single factor. So select the data. Column data is represented in columns and labels are there in the first rows, X1, X2, X3, and 5% level of significance. And click OK. So we will obtain the output like this. And what this output tells, let's briefly discuss about that. The first table, this indicates about the summary statistics. Summary means summary of all these samples, X1, X2, X3 sample, their mean, the average, variance, etc. The ANOVA, now this is the final output table for this one. What it indicates, ANOVA is having these sources, these things. ANOVA table, source of variation. There are 2 sources of variation between groups. Between groups means X1, X2, X2, X3, X3, X1. Within groups, inside the data set. The total variation is divided into 2 components. One within आपस में population 1, population 2, section 1, section 2, and within एक sample के अंदर, एक population के अंदर how much variation is there, means among all of them together. This is sum of squares. Sum of squares is nothing but the numerator of the variance formula, x minus x bar whole square, if you remember. The same thing is there. This is between groups. This is within groups. These are degrees of freedom. Degrees of freedom are also the same concept. Here, the total you can say 15, including all the populations 15. So degrees of freedom are n minus 1. The total are coming as 14, 15 minus 1. Between groups, 3 samples are there. 3 different samples are there. So 3 minus 1, 2 degrees of freedom. And the balance, these are the error degrees of freedom. These are 14 minus these 2, that is 12 degrees of freedom. Mean squares are being calculated and the finally F value is this. Now this F value need to be compared with the table value. F table value is like this. In the same manner, the F table value need to be seen based on this degrees of freedom. एक रो में आपका न्यूमरेटर डिग्रीज ऑफ फ्रीडम रहेगा, एक रो में आपका डिनोमिनेटर डिग्रीज ऑफ फ्रीडम रहेगा. Based on that, we can locate at 5% level of significance. This table value will be there. Now this will be compared with that F value. As the F ratio is less than the critical value, the table value, so null hypothesis may be accepted. It means that all the populations, these P1, P2, P3 are on average same. There is no significant difference observed. And another approach, that P value or the significance value, it can be compared with the level of significance. As P value is 0.67 and the level of significance is 5%, that is 0.05. So null hypothesis may be accepted as P value is greater than the level of significance. So this is a brief idea about analysis of variance with the help of Excel. So from my side for today, this much, sir. If anyone have any question.
Yes, sir. Yes, sir.
Yeah, please.
Sir.
Yeah, please let me know if anyone have any query in this.
Yes, sir. Yes, sir. Yes, sir.
बताइए.
Sir, what is the difference between sir P value and the critical value? And if the population is heterogeneous, then we use analysis of variance only one way or two way?
One thing, the first question is, what is the difference between P value and critical value?
Yes, sir.
Actually, there are 2 ways to conclude about the acceptance or not acceptance of null hypothesis. One value is traditional value, traditional approach, where we see the table values. That is F critical value is the table value. This F critical value is the tabulated value. From table of the F test, which can be seen. And this p-value, there is a formula for calculating p-values for different tests. There is different way of calculating the p-value
Yes.
manually. But p-value, what exactly the p-value is? It is the probability. Just one second, let me explain, give you the definition of this. It is the probability value. It is
Yes.
defined as the probability of getting a result that is either the same or more extreme than the actual observations. P-value is known as the level of marginal significance within the hypothesis testing that representing the probability of occurrence of the given event. Means कहने का मतलब ये है, ये एक प्रोबेबिलिटी वैल्यू है जिसके बेस पे हम अपने लेवल ऑफ सिग्निफिकेंस से डायरेक्टली कंपेयर करके डिसीजन ले सकते हैं अबाउट द एक्सेप्टेंस और नॉन एक्सेप्टेंस ऑफ नल हाइपोथेसिस.
Sure. Thank you, sir. That means probability value is comparing directly with the level of significance at 5%, at 1%, at 2%. We are
Yes, yes,
comparing
yes.
the. Okay, sir.
Yes. Means both the approaches are same. The result will remain the same. Result will not be changed. But as softwares are being used, so softwares p
Yes, yes, sir.
value और p value और
SPS,
significance value इन्हीं को यूज करके डिसीजन लिया जाता है.
sir, दूसरा ही critical value, or critical value is also called a rejection region. Yeah, not critical value is a point where we reject the normal curve at the graph. That point, it gives an indication whether you reject the hypothesis or whether you accept the hypothesis.
Yes, yes, yes. Critical value is towards the tails of the, when we see that normal curve, that is way of representation. That why what this critical value means. Critical points can be obtained कि within this in range के अंदर रहेगा, then it may be accepted. If it is going beyond those range, graphically we are trying to understand, then going beyond those range, then null hypothesis may not be accepted.
Okay, sir. Okay, sir.
And one-way ANOVA is performed when only one factor is being considered. And two-way ANOVA can also be performed where more than two factors are involved in our study.
Yes, yes. It is also ANOVAs are parametric tests.
Yeah, ANOVA are parametric. There are
Yes.
non-parametric ANOVAs. ANOVAs are also there.
Yes, 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 sir.
Parallel to each parametric test, you will find a family of tests of non-parametric tests.
Sir, actually, I'm a statistical student, Ph.D. in NIILM University.
Okay, okay, very good.
Okay, thank you.
So, any other question anyone have?
Sir, can you start a program regarding SPSS on research methodology and others? Some programs like SPSS.
Okay. Yeah, that can also be done. SPSS make the things more, you can say, with respect to the data. Usually, it is targeting for the social scientist, but it doesn't mean only the social scientist can use that. Anyone can utilize that, and they are also providing very good results. Their data management will be more convenient. Once we need to understand the concept of that, how the data can be entered, then it will be very much easy for us in SPSS.
Yes, thank you, thank you. Okay, sir.
Yeah, please. Any other participant have any question? Please let me know. Yes, please. Anyone have any question? Please let me know. Otherwise, I request the organizer, Dr. Rekha ji, Dr. Rajesh ji, Sandeep ji. Yeah, one question is there in the chat box. Yes, there is a way to determine the question is there any way to determine the most suitable analysis method? We need to see the conditions, or you can say every statistical test is bound to certain conditions. Those conditions are called as the assumptions, or named as the assumptions. We need to go through those assumptions carefully, and we need to understand what those assumptions are. After that, we need to see our situation, what type of data we are having, what kind of situation, what kind of objectives I am proceeding with. We need to try to see how those assumptions are are feasible in my situation. which assumptions are very much feasible of test 1, test 2, test 3, test 4, where you find that the conditions of those tests are very much similar with the conditions based on which your objectives are established. That statistical test can be most appropriate for your situation, for your data. In this way, you can try to identify. For that, I also suggest you to make a table on one side. For example, t-test, as a t-test we are using, one application of t-test we are using, that is independent sample t-test. So they are having 4 or 5 assumptions or conditions of this particular test. So make a table of three columns are there in that one. In first column, write down the assumptions of t-test. In second column, write down the relevance of that assumption in your situation. It will assist you to determine how those assumptions are established or very much relevant in your situation. If those are matching, then you can proceed with that. I
Okay, sir,
hope I am
thank you.
able to answer you, Yusurbi.
Yes, sir.
Okay, thank you. Any other question anyone have?
Okay, thank you, sir. It was
Thank
a
you, ma'am.
very informative session. Now I welcome Dr. Richa Moore, Dean, School of Sciences, NIILM University. Please come for vote of thanks. Dr. Richa,
Yes.
over to you.
Good afternoon. Good afternoon, everyone. Well, Dr. Richa Moore this side from NIILM University. It's my privilege to thank you all on behalf of NIILM University as we conclude this engaging workshop on statistics and data analysis. First of all, I want to extend my gratitude to management and administration of NIILM University for the valuable guidance. And definitely, I can't thank enough to Dr. Vijay Kumar Gehlawat, Associate Professor, Department of Interdisciplinary Sciences. So, what a presentation! I can't thank enough you for the time you have given us, for the wisdom you have shared with us. What an engaging presentation, the depth of your presentation, and the time that you spare for us truly show how dedicated you are as a teacher with your student. We are truly thankful to you. We can't thank you enough, sir. We can't really thank you enough.
Thank you, ma'am. Thank you very
In
much.
the uh, such an engaging presentation. Actually, you recapitulated all the concepts of statistics and data analysis, all the major concepts, what not, starting from data collection, then type of data, then data processing, data analysis, measure of center tendency, measure of variance, ANOVA, what not, t-test, normal distribution curve. You have left not even a single topic. So we are really grateful to you, sir. Really, my words, I'm falling short of words in acknowledging your efforts and the time you have spared for us. Thank you so much, sir.
Thank you very much.
And in the end, I want to thank the Center for Professional Development, who has been a key contributor in arranging these kind of valuable lectures for us. So thank you. It was really, thank you all and the participants. I really want to thank you for your patience, and I hope takeaway from this workshop cannot be summarized in one line, because the Gehlawat sir contribution is just amazing. The depth of knowledge he has shared with us is invaluable. So thank you everyone for your patience, for your time, and good day everyone.
Thank you, ma'am. Thank you very much.
Thank you,
Over to
sir.
you, Dr.
And thank you, ma'am. Now this session is completed. Please all can leave. And thank you everyone for joining.